Hi friends, welcome to the learning series of Red Hat System Administration or RH133. I'm Harshit Srivastav, your course instructor, and here in System Administration we are going to cover a huge range of topics. System Administration is a vital section, component, which you would need to be prepared of for pursuing Red Hat certifications, or if you are simply learning this Red Hat course for administering your system. If you want to be a master of Red Hat, you must go through this process. So what are the topics that we are going to learn here within system administration? So we will start with system initialization, which deals with the boot process, the bootloader, and everything that exists between when you start your system by pressing the power button till an authentication screen appears on your screen on your desktop where you will write your username and password, all the process behind that thing. Then we will learn about RPM, Red Hat Package Management. Then we will learn about kernel services. Uh, Linux is actually a kernel, and Red Hat is an operating system. So to properly use the power of open source, we have to be aware of kernel services, not just aware, but master it. We will be exploring the kernel services and trying to control it and learn about everything. Then we will learn about system services that are in user domain, not the system domain, the kernel domain. Then we will learn about user administration, where the user information, the configurations, and other things we will be dealing in. Then we will learn about file system management in advanced level. The file system management allows us to manage the file according to us, all the files, the folders, their path, everything. Then we will learn about network configuration, where we will be learning about the network systems. If you want to configure the LAN or basic configuration with a server, then we will be learning about the virtualization, which is a trending topic these days. Virtualization is being used along with the cloud in Linux to empower present scenario servers and everything. All the applications these days are powered with cloud, on cloud, run in background with Linux operating system, either powered by virtualization or containerizations. The Docker and Zen are very popular. So Zen is a virtualization tool which is being used with Red Hat, and obviously Red Hat is an important component of AMI, Amazon Linux, which is the default operating system for when you consider the EC2 or other services on AWS. So we will be learning about Zen. Then we will learn about troubleshooting at last, about system administration, all we have learned. So without wasting any time, let us start with system initialization. So go. The boot sequence is the thing which is appearing on your thing. When you start your system, press the power button, the system begins to boot. What is booting? For those who don't know, there is a piece of code, actually, our first line of code that is being executed when current begin to flow in your motherboard circuit. And the first code that is being executed is the boot code, the bootloader, which is located in the primary section, primary partition of your hard disk, and it is being loaded in the cache. So the boot process starts, which consists of a bootloader. After the bootloader is being loaded, the kernel is being initialized, the main kernel thread, which starts the parent of all process on your system, that is init or initial, INIT, which is very interesting, and enters the desired run level. Run level is you could also understand by safe mode. the example of safe mode. If you have been using a Windows operating system over a time, you might have seen safe mode in XP and 7. The safe mode is nothing other than run level, but here is a difference. In Red Hat, we have multiple multi-level run level. So there are 7 or 8 various run levels which we can define and execute. So here are the 3 commands or files that is being executed behind the scene from bootloader, kernel initialization, and initialization of the parent process init. All are loaded from etc location, and rc.d, the D stands for daemon. It loads. The system init process is being called. Then other daemons and local daemon is being loaded. The bootloader consists of 2 stages. First stage, second stage. The first stage is small. It consists of a less number of files which resides in MBR or boot sector. Boot sector is the key sector of your hard disk, of your storage device. Then comes the second stage where the partition is being loaded, which is being loaded from the boot partition, which you create during the installation of your operating system. If you're dealing with hacking, ethical hacking or other part of things, you have been aware about boot sector viruses. Boot sector viruses are the most horrible virus. If there is a boot sector virus, you could not kill it. The concept is very simple. The software which you use to find and remove viruses is called antivirus, which starts after the bootloader is being started and system process has been initialized. When the virus starts before the antivirus itself, you could not stop it. Nothing can stop it. So to secure boot sector is very important if you're dealing with a server. When you are going to be a server administration at certain organization, you must be aware of the threats that may someday attack on your system, and you have to prevent those attacks. So be aware about boot sector virus. Then the minimum specification for Linux is determined. The labels are being used, the kernel location where the kernel is there, kernel files are located, the operating system, root file system. Root is being loaded first, then you will be asked the user which user want to access. If you provide root or non-root user, it will go to that user's account. You will be logged in with that account. Then the location of initial RAM disk is being loaded, that is init rd, which is again a daemon. Then minimum specification for other OS, that is a boot device or level, could be done. Then there comes the Grand Unified Bootloader or GRUB, which is located in the file called grub.configure or grub.conf. Grub is a command line. Grub is a bootloader, the default bootloader for Red Hat, which is very powerful, which can load multiple operating systems at the same time. Try to remember the days when you want to install Windows and Linux simultaneously on a system. You have to first install grub or Linux at the first. Then you would install the Windows in other partition. So the grub would be the parent process, parent bootloader, which could start Windows or Linux at the same time. You can switch that about that. So it unifies all kinds of bootloader at the same place. It is very powerful, and Red Hat is being configured with grub. You can configure the grub with this file You can also go with command line interface that is available at boot prompt. You can boot from which can boot from the partition 2, ext2 or ext3 or various other partitions. The bootloader file could be located in a hard disk, SSD, pen drives, compact disc, and various other devices, storage devices. So be aware about bootloader. It supports a MD5 password protection, which is an encryption. Uh, the grub.configuration file is located in the boot directory and within the grub. The changes to this file could take effect immediately after you write the changes. So have a precautions over that. If MBR on the location dev SDA is corrupted, you can reinstall the first stage bootloader with the command sbin grub install dev SDA. The bootloader, the copy of a bootloader is located here in the sbin. We can start the boot process with grub. The process starts with the image selection, image of the OS. We select the space followed by up, down arrows on the boot splash screen. So what is image selection? The same process. Suppose in our desktop or laptop, we have two operating systems. Actually, the operating system is called as image, the Windows image, and one Red Hat image. Windows 7 and Red Hat. Take it as that. When the grub bootloader is being initialized, it started, and it will show you the options. Either you want to load Red Hat or Windows. You could select anyone from them because you have provided the image for those operating systems. You can select by up and down arrow. If there is a single image provided, it will not ask you. You can similarly simply go with your default image. We can also pass arguments which can which allows us to change an existing stanza in menu editing mode. We can issue boot commands interactively on grub command line, which is specifically a threat if you are trying to hack the Grand Unified Bootloader. There is a threat out there. You can switch off various modes of the grub, which won't allow anyone to pass arguments when the grub is being loaded. Be aware of that. Then there comes the kernel initialization, which happens after you selected the image. The kernel boot time functions start with a device detection, the detection of all the devices, device driver initialization. The initial drivers are being initialized, the USB driver, the sound driver, uh, other drivers as well. Then then it mounts the root file system in read-only mode. The root file system, the file system of your system with a root user is being loaded at first, but it will be only displayed. You could not write it or edit it. Then loads the initial process, which is called init or parent of all process. You have been typing a command called init init 0, which can shut down your system. It will shut down your system. So we can pass the value 0 to the init process, and it will kill the init process. When we kill the parent process, all the child process or everything that exists on your Red Hat system would automatically be killed and the system shuts down. Similarly, if we want to restart our system, we will write init 6, which will show the status code of 6 to the init process, and the system restarts. So this is the clarification of the init process. The init initialization is being read from the configuration file, which is again located in etc and init tab directory. What does init actually do? It initializes the run level, the default run level of your system. Which is being followed by system initialization scripts that are being executed uh, to load the kernel and everything else. The run level specific script directories are being located. It traps the certain key sequences. It defines the UPS power fail restore scripts. Spawn Gettys on virtual consoles. The virtual consoles that you see, there are 7 virtual consoles, 6 command line consoles or virtual consoles, then the graphical console. Then it initializes X in the run level 5, initially in run level 5. So here comes run level, where init process defines run levels. There are 7 run levels from 0 to 6, then S and emergency run level. S could be considered as safe mode. 0 to 6 are different run levels, and emergency run level. Run level is selected by either the default in the etc directory with init tab. At boot passing, bootloader loading with an argument from the bootloader, you can define run level by pressing the status code when the bootloader, the grub is being loaded, or you can provide it from command line init new run level. You can create a new run level, load run level, change run level, and by default, a normal run level 5 is being loaded. To show current and previous run levels that was executed, you can go to sbin and run level. Then there comes another important file, that is rc.systeminit, the system initialization file, which is a daemon again. It does perform important tasks for activating UDEV and SE Linux, the security enhanced Linux, which is a security feature which is securing the kernel and other system utilities. It sets the kernel parameters in system control.configure in the etc directory. It sets the system clock, the date, time, and everything is determined with this process. It loads the key maps or key stamps. It enables swap partition, the partition which is being loaded. It sets the host name. It loads the root file system, check and remount it. It activates the RAID partition and LVM devices, low level virtual machines. It enables disk quotas, the quota assigned to different partitions or disks. It checks and mount other file systems, uh, where if you place a pen drive that is another file system not native to your system, it could be mounted and being checked by this process. It cleans up the stale logs and PID files. Then comes the system V run levels. Run levels define which services to start. Each run level has a corresponding directory, the same directory, etc rc.d, rcx.d, where x is the run level, 0, 1, 2, 3, 4, 5, 6, s, and so on. The system B init script resides in the init path, init.d daemon. The symbolic link in the run level directory would call the init.d the daemon scripts, the init script, with a start or stop argument. So it would determine which run level to load. These files are vital if you want to configure the system. You have to configure after the system is being loaded. You can configure it for all the next times or other times when the system boots up. You can determine which run level to load, what to configure, and go through these files. Then there is another file that is called rc.local, which is being executed after the run level specific scripts are being loaded. It is a common place for custom modification. In most cases, it is recommended that you create a systemd init script in this file. Init.d, the daemon file for init parent process, is used unless the service you are starting is very important and it doesn't guarantee it. Existing scripts can be used as a starting point for this local script. So this is a process of loading the bootloader, image, run level, init process, the kernel, the local file. You can control various services and process with utilities. There are different utilities to control default service startup and to control services manually. If you want to control the default services at startup when the system is being started, you can go through system config services, ntsysv, check configuration. The system config service is a graphical utility that requires an X interface, which is an X window interface actually. X window is the genome or KDE, the graphical mode, or the GUI interface in Linux. The ntsysv is based on a utility usable in virtual consoles or the command line modes. Then we can go with check config, which is fast, versatile command line utility that works well and is usable with scripts and kickstart initializations. We can manually control various services and utilities with the service command, which immediately starts or stops a standalone service. We can use the check config to immediately start or stop xinetd daemon managed services. So this was a brief introduction about system initialization. We have learned everything from the power on button, what are the processes that exist, go through this thing in detail, check the various files, explore the files that we have learned about here, and try to read those files. You actually don't need to configure it if you are not an advanced user or administration. Basically, you must have an idea what is going on behind the system, because attackers can attack at any level and you have to be cautious about everything. You can do a routine checkup of these things if you are being aware of the process. If something is not going correctly, you can always check it if you know what are the correct sequence. So keep learning, keep moving ahead. We will be learning more in the coming videos. Welcome back, friends. We are learning about system administration, and this is second lecture on system administration. Here we are going to learn about package management, the RPM, and other things. So let's start. So what is a RPM package manager, which is Red Hat Package Manager? Uh, the Red Hat Package Manager is a tool which is similar to software installation tool which occurs in Windows and Mac. Here you can configure which software is to be installed or removed. You could query various things, and you could verify the package management. It is with distribution, installation, upgrading, and removal of a software on Red Hat Enterprise Linux. And the RPM system consists of the local database, the RPM and related executables, RPM front ends such as yum, which is a command which is that could be used to install or remove an utility or a software via command line mode. It allows you to package files, various files. The local RPM database is maintained in the directory var/lib/rpm. The database stores information about the installed packages, such as file attributes, the package prerequisites, and you are being an administrator, you rarely, if modifies the database directly. You can instead use the RPM command, which could be used to directly modify the database. The software could be installed using RPM, is distributed through RPM package files, which are essentially compressed archives similar to zip or gzip of files associated dependencies information. The package files are named with various formats: the release version, architecture, and RPM. We will learning about this thing in next pages. So let's move to installation and removing of softwares. There are various RPM options available there. You can install a software with the command RPM-I for installing a file, or either you could use minus install. To upgrade a system or utility, you could use RPM-U. To update to a fresh version of a tool, you could write RPM-F, which freshens your system, removes the earlier version, and installs a new version by downloading and installing. You can similarly erase a version with RPM-E. There is a syntax of writing this thing, as you can install. Suppose we want to install a file, we have to write RPM-I hash, the pound symbol, zip. Suppose we have a file named zip2. You can have ABC or any file name. Then place a dot that defines the version. Version here is 2.38. Then there is a dot which defines the architecture. Here we have x86 i386. Then place a dot to define the Red Hat package management RPM file. So this is the syntax of providing the RPM command. You can install, upgrade, freshen, or delete, erase with this command. Similarly, you can provide output with options -v and -h. You have an URL support for FTP and HTTP. There are many other install options that are available to address various special cases. You could go through various options in detail, but actually they are rarely used. Then there comes the updating of a kernel RPM. When you are updating a simple file, that could be a utility like links or a web browser, you could roughly use RPM-U or RPM-F command. But when you are upgrading a kernel, you should not use -U or -F argument for various reasons, because when you write -U and -F options, it determines whether a version already exists on the system, and if so, if the version exists, whether the version to be installed is newer. It checks whether your new version is actually new, or whether it is old. If it is new, the RPM first installs the new version, thereby replacing old files. The old files are being deleted, except those marked as configuration file. Only configuration files are being left, rest other files are being vanished, simply gone. It then removes the old packages, but only deletes files that do not exist in the new version. Because of upgrading, it removes the previous kernel version, and if your newly installed kernel proves unstable because you don't know whether a new version would run or not, and the old kernel files have gone, deleted, you could be left with an unbootable system. The system is gone. You have upgraded your system. The previous kernel has been deleted, and your system crashes. You could not boot your or restart your operating system anyhow. You only have an option. You could you would have to restore to alternate boot media such as boot floppy or CD-ROM to boot your system. When you run and install instead of an upgrade, the old version of the kernel is still available and can be selected from the bootloader. You have to install other than upgrade or freshen your system if you are dealing with kernel. Rest fine with other utilities. You have various options like -IVH to determine the kernel version. You can boot new kernel to test. You can revert to old kernel if a problem arises when you use install version, the -IVH command. You can delete the old version if no problem exists later on. First you install a new version without deleting the earlier one. Then there comes RPM queries, which allows you to execute different queries on installed packages and uninstalled packages. The syntax for writing RPM query is simple. RPM minus Q. Minus Q argument shows that it is a query. You have to write in the format of what package, which package you have to deal with, and which information you want to retrieve. For installed packages, you have various options. RPM minus QA. The QA argument lists installed packages, all the packages that are being installed on the system. Minus QF space file name shows the owning package. Minus QI space package name shows the general information about the package. Similarly, minus QL space package name lists the files in a package. Similarly, on uninstalled package options, you could execute a minus QIP and minus QLP for a package file system. Similarly, for RPM verification, the package management verification, on installed RPM file, you could execute different commands like rpm-v, rpm-vp, and rpm-va for verification of the file, whether it is being installed or not the properly installed, and the various details you could check. You have to perform a signature verification before a package installation by writing the rpm minus import, the rpm gpg key, then the rpm minus k argument, followed by a package name and architecture and .rpm. Then there comes a very interesting thing, the yum or yum command in short, which is full form for yellow dog update. It was developed in an university, and the full form is not widely used. This command is everything if you want to install, remove, or update a package or a system or a utility or software on Red Hat. It is a front end to RPM. It is designed to resolve package dependencies. It can locate packages across multiple repositories. It is a replacement for up-to-date command. For installing a package using yum command, you have to write yum space install command space the package name with architecture and .rpm full file. Similarly, you could write a remove and update argument with yum to remove and update package respectively. You can search packages or files using the what provides argument on yum. You can search with a search term. Suppose you want to search particular string on a package, you would write the yum search with the search item, search term. Similarly, you could list everything with the argument yum space list all available extras installed recent updates and so on. You could get information of a package name with yum space info command, then the package name. You could search a particular file in the package with what provides argument. You could configure additional repositories where you can create a file in etc directory yum.repos.daemon file for a repository. The required information for configuring additional repositories is you have to provide the repository name, then name equals to a nice description about your repository, then provide base URL for a repository from where it has to be downloaded, enabled equals to 1 and GPG check equals to 1. You have to define these things in the particular file. You can create a private repository, and by creating a directory to hold your packages, you have to create a directory first, make this directory available by HTTP and FTP, which can be downloaded by other users. You can install create repo RPM, then run the create repo command with a -v argument and the package directory. You have to provide your directory for the package, and the repository will be created on repo data subdirectory and the needed support files for the file to be created as a repository. Then there comes another thing, that is a Red Hat network, which is a centralized platform for system management. It provides Red Hat software packages. It shows if errata are available for system. You can update many systems at once using Red Hat network. It allows full life cycle management. It is web-based management interface. It uses HTTPS for secure transaction or for all transactions. Then we have a Red Hat server, network server, which is rhn.redhat.com or local satellite proxy, which is a web-based management of machines. It provides proxy caches for Red Hat network traffic. RHN satellite provides an autonomous Red Hat network. You could go with a proxy or satellite based on your usage. Then there comes a Red Hat network accounts, where users for info, where RHN users, Red Hat network users, can register for machines or web-based management. A system ID for automatic authentication of system is being required, and you can use various utilities provided by Red Hat network. Then there comes entitlements, which are software channels subscribed by your system. You can grant access to software channels for subscribing by your system. The channels could be base channel, the child channels. It defines the level of service. You can define, update, management, provisioning, and monitoring of services. Then there is another thing that is a Red Hat network client, where registration and interactive usage and remote management could be done using various utilities. You can select to update location, that is RHN or local or satellite or proxy, by running the command rhn underscore register. You could enter the account information for authenticating to Red Hat network, satellite or proxy. For interactive usage, you could use the Yum plugin for downloading packages from Red Hat network. You could which you could configure the interactive usage in rhn plugin.configuration file located in etc yum. Then for remote management, you could go with rhn sd poll for every 4 hours, which is being updated every 4 hours, or for immediately with rhn underscore check rhn underscore check poll, which exists immediately. So this was about package management. We have learned about various things on package management. We can install with install, upgrade, or delete with yum. We have learned about cautions that we have to take for updating the kernel system, and we have learned about different utilities. Welcome back, friends. Now in this video we are going to learn about kernel services on RHEL. So let's start. The Linux kernel is the core of Red Hat Enterprise Linux operating system. It is the kernel's responsibility to control hardware, enforce security, allocate resources such as CPU and memory. Uh, and kernel is known as core, which is everything centralized on your operating system. RHEL. Most of the operating system is not Linux, but rather a collection of applications that make use of facilities provided by Linux kernel. In particular, the Free Software Foundation or GNU provides a great deal of utilities and core libraries that have made Linux operating system possible. So the kernel is very important. It performs system initialization, process scheduling, memory management, security, from SE Linux to firewall rules and everything. It provides you a buffer and cache to speed up hardware access, implement standard network protocols and file system format that is being defined by you or your system utilities, and Linux kernel is the core. There are multiple kernel images and variants based on different architectures like x86, x86 for 64-bit, for 32-bit, uh, Titanium, PowerPC 64, S390X, and so on. But there are three kernel versions available primarily for x86 architecture that is very popular and normally used with Intel and AMD processors. One is regular, where we have one or more processors but 4 GB of RAM or less. The processor, one or more processor need means that one or two core, single core, double core, triple core, and so on. But the RAM size is to be 4 GB or less. Then there is another version that is PAE, where multiple processors and up to 64 GB of RAM, specifically for servers, where we need multi-core processors to speed up the process like Intel Xeon or i7 with 64 GB of RAM. Then we will need to install this image on regular would be preferred over desktop and laptop environment. And then is a third image for kernel image, that is Zen, which is needed for virtualization. The virtualization needs a separate core to be implemented. It is separate from the basic kernel of your operating system because it allows you to do certain tasks that you could not perform on a single OS. So there are three images and you should be aware of it. The kernels are always installed under the directory boot VM Linux Z. Then there are different kernel modules. Modules are basically small kernel extensions that may be loaded and unloaded at will when you want to load or unload. There are different kinds of modules for a kernel, and you can check them out or uncheck anytime. You can download a newer version of modules that provide extra functionality or enhance the performance of kernel. It can be implemented as drivers that could be hardware drivers or other drivers, file system, firewall, and more. They are located basically under the directory library and modules and provide the uname directory. It is compiled for a specific kernel version. The modules are basically meant for a specific kernel version. They are not generalized. There are different versions and are provided with the kernel RPM, the package management. The third-party modules may be added, but they are not preferred. You should be concerned about security. If you are dealing with a server environment, you must be careful by installing third-party modules on kernel. You can install third-party tools or utilities on your system, but do not prefer to install third-party modules on kernel. Then there is a utility called lsmod, which provides a list of loaded modules. There are two different options for lsmod, the mod probe and mod info. The mod probe can load and unload modules. Mod info displays information about any available module. You can run these commands or you can find the GUI utility from the applications panel of your desktop. There is a configuration file called mod probe inside the etc directory that could be used for module configuration. You could configure different kinds of parameters, aliases, and commands to execute when a module is loaded or unloaded. You can configure parameters to pass to a module when it is loaded. You can also create aliases to represent a module name. You can access those from CLI mode, from Linux terminal, or from a GUI option in the configuration file itself. Then you can manage initial RAM disk, which provides modules loaded early in the boot process using the init rd command. This file is located under boot init rd and the image name. It provides you extra module sometimes needed to be added due to following reasons. When you add a new hardware to the system, for example, SCSI controller, or you may add a new feature such as USB devices, or you can add modules that need to load automatically at boot time. For this purpose, you need to configure initial RAM disk or init RD. You can use a MK init RD or make init RD with a with option to rebuild an extra module. Then there comes accessing drivers through directly dev, which is a directory for a file system. The files under dev used to access drivers. You can read from and write to those files are valid operations. Uh, Read from serial ports like the command could be for reading the serial port is cat slash div slash ttys0. For writing a serial port, you can write message in echo and provide it to dev ttyso The three file attributes determine which driver to access: device number, major number, minor number. These are the attributes that determine drivers to access. Then there are two types of devices on kernel: the device node example, the block devices, the character devices. The block devices are CD-ROM, hard disk, SCI, SATA, USB storage, a software RAID, that is an implementation of a distribution partition of automatic configuration. These could be found on the following directories. Then the character devices like virtual console, software devices, random numbers, and so on. These are the consistent properties of a kernel, the devices that could be configured with dev. You can manage dev with udev also. Udev manages file stored under dev. It manages files only created if a corresponding device is plugged in. Suppose you want to configure the pen drive, you first need to mount the pen drive. Then you can configure the files for on pen drive if corresponding device is plugged in. Similarly for SATA, hard disk and other devices. The files are automatically removed when device is disconnected. udev statements are under the rules.daemon in udev etc directory, which determines file names, permissions, owners, and groups. It also determines the command to execute when a new device shows up. You can also add files under dev with a command. You have to provide variables, the kernel variable to SDA, name, USB key, symlink, USB storage, and so on to insert a statement such as you need to create a new file under rules.d. You can create device file names with the above name and store that thing next time when the property get plugged in. Files can be added manually with mknode command by writing the command as the syntax here: mknode dev USB device b and the port number. However, mknode is not persistent. It may sometime run or sometime it may not function as you desire. Then there comes a kernel configuration, which is very important. Sometimes you need to configure kernel according to your usage if you are an advanced user. Otherwise, you don't need basic kernel configuration, but it can be found on the root directory, basically the proc, which is used to set kernel configuration. You can configure virtual file systems. You can create your own file systems. The files are not stored on the hard disk. It is virtually there. Then you can create entries that are not persistent. The modifications get reinitialized after a reboot, which is used to display process information, memory resources, hardware devices, kernel memory, and so on. You can also, configuration can be used to modify network and memory subsystems or modify kernel features. The modifications are generally applied immediately after you change the configuration. You don't need to restart your system. The proc examples include for read-only files, read-write entries, and so on. These are the links where you could go for configuration. The proc sys or directly proc. Then comes a persistent kernel configuration that exists for all the time. The persistent and non-persistent, the difference between these two are things that non-persistent configurations are applicable till only your computer is on. If it is restarted or shut down, the configuration, inconsistent configurations get lost. And next time when you start your system, if you have configured persistent kernel configuration, they exist. Then there is a command called sysctl, which adds persistent to proc sys settings. Statements added to the configurations sysctl.configuration automatically get reflected under proc after a reboot. They need rebootation. You need to reboot, restart, and it becomes applicable. The configuration is maintained or monitored using a sysctl command, which is used to, there are certain parameters. For example, if you want to list all current settings, you may write a command like sysctl-a on terminal. To reload settings from sysctl.configuration file, you can write sysctl-p. To set a proc value dynamically, you can write the command with IP version 4 and the forward X parameter set to 1 and so on. You can explore hardware devices with a snapshot of all connected devices, which is being maintained by hardware abstraction layer or HAL in short. Uh, you can write command HAL -device, which lists all the devices in text mode. Then you can write a command called HAL-device-manager, which displays all devices on the graphical window. Then there is two other utilities, LSPCI and LSUSB, that lists devices connected to PCI and USB buses. It is similar to ls command, the list shell, which shows the directory, the file and folders contained in a particular directory. Similarly, the LSPCI and LSUSB list all the devices connected on PCI and USB buses respectively. The proc and sys file systems also contain bus and device specific information. You can also go through them directly using the GUI options. Then there comes monitoring the process and resources that are running on your system in the background and the foreground. The informations available under proc can be hard to understand directly, specifically for non-developers or those who are not familiar to complete Linux kernel or first-time users. You can go consider other things like the interfaces that are available to format the data and make it more accessible. You can go through memory, process, and kernel states. The memory could be accessible by free, vmstat, swap-on, -s, pmap. These are the commands or utilities that you can use to access the memory information. For process information, you can write the command ps top ps3 genome system monitor, which is a GUI utility, and you can to check kernel state, you can write the command uname, uptime, tload, and so on. These are the commands. You just need to type those commands. It will show you various options. You can also check with manual command man vmstat to get a complete list of the manual. This is a simple format. Nobody knows all the commands actually. You don't need to remember these commands. If you're finding it troublesome, you don't need to remember actually. You can go through the reference. You can download these videos. You can directly reference your work uh, and go through the manual. It will show you all the options available there. The arguments are not required to be memorized. You just need to remember few commands of your use. Write the command, write man in before writing the command. Man provide a space and your command name. It will show you all the arguments and usage of the command, which is simply a help option. That way you could learn the commands better, and you need to only remember those commands and arguments which you need. There are thousands of commands or options available on a system. How much you can remember? So this was a simple kernel configuration file and whatever we learned about kernel, Linux kernel. We will be exploring more in the coming videos. So keep learning and keep moving ahead. We have learned about kernel services, and now here in this lecture we are going to learn about system services. That includes a wide range of topics which is important to synchronize time We could use system logging, X window system setup, remote administration of the system, and automation of tasks with cron. We can configure printers and various things. So let's start with NTP or Network Time Protocol. So NTP is used in certain cases where we need applications uh, that could not use a hardware clock of your system, which is not accurate enough for a wide range of applications, and it tends to drift over time. Many applications require exact timing synchronized over a network, the same time for all computers, all devices, and for providing the accurate time, the common time, we need to bypass the hardware clock and provide a new kind of a standard that is called Network Time Protocol or NTP. The workstation hardware clocks are not used, and the NTP is preferred over that thing if you want to run network utilities like file sharing, internet, and other utilities. NTP counters the drift by manipulating the length of a second. It could change the length of a second. NTP clients should use 3 time servers. The configure file is located it with ntp.conf in etc directory, where we can configure NTP. A configuration tool is available with system config date as a GUI utility on Genome. Time synchronization is used to make system logs easier to analyze. The logs are things that are written with timestamp. Uh, the NTP provides a useful instance for that thing. We want to check the time, the correct time and date where a system entry was initialized. Anything could be performed. If you want to troubleshoot or like black box or white box testing. Then there comes a system login, which is a useful thing when it comes to system analytics. The centralized logging daemons that are syslog d. The D means daemon simply. The suffix D is daemon. It stands for daemon. Syslog or klog. Klog means stands for kernel log, and syslog stands for system log. We could check these log files. The log file examples could be checked on kernel boot message with a D message in log under the var directory. Similarly, we can check standard system error message, email system messages, security authentication, and init messages. The application log files and directories are located in var/log, where we can check application log files. The syslog or system log configuration for system V initialization script is located in etc/rc.d initd controls, which controls both the system log and kernel log daemons. The syslog.conf is used to configure system logging, and the directory for syslog in sys configuration under etc directory is used to set switches, which is used when starting system log and kernel log from the system v initialization script. Then there comes an X11 server or XORG, which is a foundation for Red Hat Enterprise Linux GUI. The X window system, or which is also called X or X11, is the foundation of the graphical user interface on RHEL. The X window system is maintained by the X consortium, and which creates a reference implementation of X under an open source license. XORG project is an add-on hardware driver for a variety of video cards and input devices, along with several software extensions to manage the visual representation of data. Xorg or X11 or X window, which is also implemented with Genome or KDE, is nothing other than the graphical implementation. You may need it or not require it, but the graphical thing is very important when you want to manage those things in a user-friendly manner. You can also go with the command line interface, virtual console, but the graphical console is most preferred to a normal user or various kind of users. So you can configure it, you can check it, install it, the X11 server. It is open source implementation of X11, the Xorg. The drivers are ATI, NV, mouse, keyboard, which are being managed by Xorg. The extensions are DRI, GLX, and XMod. It allows you to render fonts using XFS, the native server, or the font config, which is located as a library. Xorg consists of one core server and several dynamic loaded modules. The server core is hardware independent and is extended through the configuration and loading of hardware and X11 extension specific modules. The kernel's module directory. Uh, like the OS kernel, through the combination of unique hardware specific modules, the X server design remains flexible, and in fact, when the server is invoked, it scans and rectifies the configuration against the hardware. It checks the hardware, seeking the optimum display and the input capability. The XOR configuration is here. Typically configured, it is typically configured after installation of the OS. The best result is shown while running in run level 3. The system configure display is a GUI utility which can be accessed by application on GNOME desktop. You have various options and it is stored in the etc directory of x11 xorg.configuration file. Running xorg in run level 3 has a simple consequence. There are two methods to stabilize the environment, the xinit and startx. We have learned in the essentials that startx command is used to go to the graphical console from a virtual console, the command line interface. If a GNOME or KDE is anyway not loading, you can write this command startx, or xinitd could be used to establish the xorg environment. The environment configuration includes these files, which could be written and configured in the desktop and other places. The Xorg could also be executed in run level 5, which needs environment establishment in SBIN init. The environment configuration includes the following files: the etc sysconfig desktop, etc x11 pre fdm. It consists of two variables. The desktop variable which defines the window manager, the display manager that defines the display manager. These are the options. Then there comes a remote X sessions that is used to access a system remotely, either by making the system as a server or client or any other thing. A thin client, fat client, a wide range of things could be implemented. The X protocol communication is unencrypted, it is not encrypted, and so not safe as compared to SSL and other protocols. The remote X is most primitive. It is host-based sessions implemented through xhost command. The user-based sessions are implemented through xauthority mechanism. The SSHD may automatically install xauth keys, authentication keys on remote machine, and it uses a tunnel X protocol over secure unencrypted SSH connection. It is secure but uh, sorry, secure encrypted SSH connection. The remote X is as it is not very secure, but when you use a SSH with tunnel X protocol, it becomes a secure connection. Then there comes a SSH, which is secure shell. It is encrypted remote shell. You can access the environment remotely. It is frequently used for remote system administration It is used widely. Suppose you have a server environment implemented on Red Hat at your office data center, and you are the admin of the data center, and someday you are in a vacation trip and you want to access certain files on your system and you want to configure it on your server, you need to create a secure shell remote login, which has to be configured earlier so that you can access it remotely and change anything, whatever you feel like on your system. You can copy files securely, you can execute commands remotely even. The execution of remote command is a very good facility, but the facility may prove fatal when it comes to security. So a proper configuration is vital. SSH command is used for authentication. SSH root at the rate host provide the host name. A root is a username. Then in the codes ifconfig eth0. If you are configuring SSH secure shell authentication for remote access, you should not configure it as a root user, because a root user, if misused, could fatally harm your system. It could access anything, any file, anywhere. You simply need to provide access by creating a non-root user accessible for a certain file systems. But if you need a control, you should be available at your data center for security purposes. It can tunnel X11 and other TCP-based network traffic. It supports key-based authentication. You can authenticate via digital signatures and other tools as well. Then there is another thing that is called virtual network computing or VNC, which allows you to access or share a complete desktop over the network. A complete desktop, the sharing of the complete desktop. You might have used a software called TeamViewer to access your system from mobile or other devices. VNC is simply a TeamViewer. It is the primitive thing. The TeamViewer is implemented using the VNC. The VNC could be configured in a two-way, a server and client. A server is an individual user that can start a VNC server with the command VNC server. By typing the VNC server command on a Linux terminal, you could initialize the VNC server. You have to run the home variable, path variable upon startup. It requires a VNC password which should not be identical to the system password, because the system login you would not be interested to provide to other users. Servers can automatically be started via etc init d VNC server, and you could also install use of the client. You have to install the client as well. The client is something that connects to remote VNC server with a VNC viewer. Suppose we have two computer A and B. We need to access computer A via computer B. So we need to create A as a server and B as a client. And client provides unique screen numbers distinguishing between multiple VNC servers running on the same host. It supports tunneling through SSH, VNC viewer via user host, a local host. Then there comes a cron job, which allows you to schedule recurring events, the events that occurs uh, over a time. If you want to execute various things for execution on a later time period, you could use this thing. The the cron table file or cron tabs in short are stored in the particular location. You can use cron tab to edit, install, and view job schedules. The syntax for using the cron is the cron tab command provide a username and the file. The another the cron tab, the -l, -r, or -e argument. The -l argument lists the cron tab. R removes the cron tab. E edits the cron tab using the editor. The cron tab can be either edited in the current directory and installed by using it as an argument to cron tab or by using -e option. Events scheduled by crons are run by the cron D daemon, which must be running on the system. Fields in a cron tab can be separated by any number of tabs or spaces. You can delay a file with a minute, hour, day of month, or day of week, anything. The syntax for writing a cron tab is man 5 cron tab. Suppose man is a manual command, 5 is a provided day, a month, date, and the cron tab is the cron tab. You can control access to cron. You can restrict allow user access to cron using the cron.allow or cron.deny file located in etc directory. It contains a username to allow or deny access. There are system cron tab files as well. It is different. It has different format than user cron tab files. The master cron tab file runs executables in hourly, daily, weekly, and monthly period. The cron.d file located in a directory contains additional system cron tab files. There are daily cron jobs that execute on your system on a daily basis. When you use your system, the temp watch, which is used to clean old files in specific directories. It keeps temporary from filling up the temporary directory, which stores the temporary files you have to delete. If you are using a Windows system, the %tmp command is used to allocate the temporary file, and you are required to delete those files over a period of time. Similarly, TempWatch is an implementation on RHEL. Then there comes a log rotate, which is also a daily cron job, which keeps log files from getting too large. They keep it short or compressed. Highly configurable. It is very highly configurable. You can configure it by accessing the log rotate.configuration file in etc directory. Then there is a log watch, which provides a summary about system activity for suspicious activities and other things that you want to check. You can report suspicious messages. It could be configured on logwatch.configuration file, again located in etc logd conf directory. Then there is another thing that is called anacron system. Anacron runs the cron job that did not run when computer is down. When the computer is on, powered on or running, the cron jobs are being executed. When the computer is off, it could not execute. The simple concept. The anacron run the cron jobs which have been scheduled using cron for a certain date or time. Suppose we have scheduled a certain thing to be using the cron for executing on 24th of November in the night, uh, 2 a.m., and that time our system was turned off, and the task have been postponed. We can configure that task again with anacron. It will run afterwards. It assumes the computers are not up continually. It is vital for laptop, desktop, workstations, and other systems that are not up continually every time. It is useful for servers that need to be taken down temporarily due to traffic and various purpose. It is a useful thing. You can configure this with Anacron tab in etc directory again. It has 4 fields. The field 1 is used to if the job has not been run in this many days. The field 2 is used to wait the number of minutes after a reboot and then run it. Field 3 is used as a job identifier, and field 4 is used the job to run. Uh, when cron runs in run parse command, the first command to run is 0 anacron. This command sets up a timestamp in a file and that notes the time that it was last run. On boot up, the anacron command runs. When a system starts, the anacron runs. The purpose of anacron is to run cron jobs that may have been down. Then there comes another thing that is called CUPS or Common Unix Printing System. In short, it supports many advanced features such as printer pooling, automated client configuration, job redirection, and others. The Internet Printing Protocol or IPP is based on HTTP 1.1. The web-based management console of CUPS can be reached on port 631. By default, only members of the sys group can connect. The console can also be used for configuration. It allows remote browsing of printer queues. It is located with a cup sdconf file in cups etc directory. For printer configuration, you can check the configuration tools. It is not a very technical thing. You can go through it when you have a printer or internet utilities configured in a queue. So these were a few system services that we have learned. Go through them in depth. Explore various configuration files located in the etc directory specifically. Try to read them if you want to be a good administrator. The cron job and anacron is a very useful thing. You can go through them. They need not to be configured using command. You can also configure on the configuration file. Uh, and these are vital things that you must be aware of on Red Hat. You can always check the log files and you must secure your system. And if you want to access your system, you should use a secure shell with non-root access. That way your server will be safe. Keep learning and keep moving ahead. We will be learning more in the coming videos. Friends, we have learned about the kernel services and system services. And now here in this lecture, we are going to learn about user administration. The user administration, we will be learning about configuring user and group accounts, modifying file ownership and permissions, use special permissions or SUID, SGID, sticky keys, configuration of network users with NIS and LDAP, and set ACLs. We will be learning these things here in this lecture. We have already learned about users, groups, and other related information on primary level in the essentials. And now here in this video, we are going to learn about them in detail. The first thing with user account is to add a new user. We can add a new user by using the common method called user add command, which have various options and a username. You simply need to write user add, write any option like -a, b, and so on, and provide a username, the name you want to pass as a username. It could be used for running user add, which is equivalent to editing the password in etc, the shadow file, a group, and gshadow. It create and populate home directory. It set permission and ownership. You can set account password using the password command, PASSWD. We have learned about this thing earlier. Accounts may be added in a batch with new users as well. Then there are user private groups. When a user account is created, a private group is also created with the same name. Users are assigned to this private group. Users new file affiliated with this group. The advantage of using a private group is that it prevents new files from belonging to a public group. Any file which is being created by a user is not public by default. It is a private. The disadvantage is that it may encourage making files world accessible, like the default, everyone could access it. We can make files public in general cases. We should not do that thing. Then comes modifying or deleting user account. After we have created a user, sometimes we may need some point of time to delete a user. For cases like when an employee left an organization, we need to delete that person's user account, or if we want to delete a suspicious account or any other reason. To change fields in a user's etc password entry, you can edit the file by hand. You can use user mode with options and provide a username to modify the entry of user. To remove a user either directly, you can use the user del command. To remove a user, just simply write user del, provide any argument like -r, and provide a username. It allows you to manually remove the user from etc password, shadow, group, gshadow, and email directories. Then there is a thing that is called group administration. You could configure these things. You can configure entry of group administration with etc group and etc g shadow. The shadow directory is used to store passwords, as we have learned in the essential sections. The group add, group mod, and group delete command are similarly used as users for group. To add a group, you need to run the command group add. To modify the group permissions, you can use the group mod. To delete a group, you could use the group del command. The password aging policies are there. Generally, you have created a password for your user account or group account, and those passwords last forever by default for infinite amount of time till the hardware exists. But sometimes we need to our passwords to expire after a certain period of time. Suppose we hired a person for a 6-month job and allows him some access, non-root access on our PC. On our server. We have created account and a password, and we want to expire that account over a period of time. Or sometimes for passwords, we may need certain things that, for example, users should change their password over a period of 1 month, 1 week in rotation to enable this, enforce the security concerns. By default, passwords do not expire. Keep in mind, we have to force passwords to expire. In part of a strong policy, security policy, to modify default expiration settings in etc login.defs, you could enforce this thing. To modify password aging for existing users, use the change command, the chage, not change, age. Provide the options and the username. It will change the age. Then there comes switching accounts. You can switch from different users, the root or non-root users, using the su command, the switch user command. We have already learned about this earlier. It allows the user to temporarily become another user. Default user is root. The temporary. Uh, when you log out, the user is changed. It is generally used in the virtual consoles or terminals. The minus option makes the new shell as a login shell. Then there comes a sudo command, which is used to get admin privileges to execute certain commands. Suppose we have a different commands that, for example, the installation thing. Suppose we have configured yum to be executed only by root, and if we are logged in with other users and we want to install certain tools or utilities on our system by running the yum install command, uh, we should be using the sudo command to get the privileges. We should write sudo yum install. The user listed in etc sudo users can execute this command. Not all other users could execute, only certain users till certain level. It takes effective user ID of 0, the group ID of roots group. Only roots group could access this command. An administrator will be contacted if a user not listed in sudo users attempt to use sudo. So a system administrator, the main administrator, the root user, get informed about any request or any attempt to use the sudo command by non-group user. It is a security concern as well. Then there comes network users. We may have network users. The information about users may be centrally stored and managed on a remote server. The two types of information must always be provided for each user account. The UID, account information, the UID number, default shell, home directory, group membership, and so on. And the authentication, a way to tell that a password provided on login for an account is correct for network users. The authentication configuration can be done by system config authentication option in the GUI mode of the GNOME. It is a GUI tool to configure authentication. For text-based tool, use auth config -tui, load auth configure GTK RPM. The supported account information services are local files, NIS, LDAP, ACOID, WinBind, and so on. The supported authentication mechanisms are NSS, Kerberos, LDAP, SmartCard, SMB, WinBind. You don't need to remember these things, but when you are going to configure the authentication, you should go through these things. Then there comes an example of NIS configuration. Uh, we must install YP bind and port map RPMs for NIS configuration. Uh, it is a popular service used to centrally manage system and account information. It uses one or more NIS server, each running YP serve to serve information with NIS client system running YP bind. The master server may also run RPC YPP password, which allow users to on NIS client to update the password stored in NIS. The both NIS and NIS server, client and server, must run a local service called port map, which helps remote systems contact the local program. Clients and server which communicate with each other are normally member of the NIS domain identified by an arbitrary name. It enables NIS to provide user information by going to system config authentication, the graphical utility. It actually gives us 5 text-based configuration files that are changed. Then there comes a LDAP configuration. You must install LDAP and open LDAP RPMs or run system config authentication to provide user information. You need to enable LDAP, specify server, the search base domain and TLS. You can enable LDAP to provide authentication. Then there are SUID and SGIDs, as user IDs and group IDs. They normally process started by a user, run under the user and group security context of that user. SUID and SGID bits set on an executable file cause it to run under the user or group security context of the file's owner or group. The SGID directories are used to create collaborative directory. Normally, files created in a directory belong to user and the default group. When a file is created in a directory with SGID bit set, it belongs to the same group as the directory. So SGID and SUID would allow you to configure the group and user related security concerns. You could use the ID key for a user and group. The sticky bit is another thing that is widely used. for facility. It may seem counterintuitive that write permissions on a directory would allow one user to delete another user's file within that directory. Consider, however, that a directory is really just a file itself whose content are references to other files. So deleting a file is therefore an edit to a directory files list of other files. Many users need to be able to create and delete files on temp, the temporary directory. Even if users do not actively create files in temp, many applications they run will use temp as a location for temporary files. Setting the sticky bit, the role of the sticky bit, prevent users from deleting each user's files, even though they have all full access to the directory. The sticky bit secures other users' file. With sticky bit set on a directory, only the owner of the file can delete the file, not other. However, they can access it, read it. You can write a command as here, ls minus ld temp drwrz, the permission, set permission for the file, provide the code, root, and so on with a timestamp. You can set sticky bits, like sticky informations. Then there comes default file permissions like read, write, not execute for all the defaults for a file. You can set default permissions that is to be used when a file is being created. Suppose you forget to write permissions. What permissions are there with a file? You can set default permissions whenever you create a new file and does not define a permission for the file explicitly. The default permissions is associated with that file. Read, write, and execute is the default for directories. Unmask can be used to withhold permissions on file creation. Users unmask is 0 to 2. The files will have permission of 644. The 7 is the combination of read, write, and execute, as we have learned in Essentials. 6 is read, write permission. The 4 is simply read permission. 5 is read plus execute. The files will have a permission of 6 for the same user, 4 for the group of the same user, and 4 for rest other users. Similarly, for directories, they have permissions of 755, and it may need to change to 002 for group collaboration. You can grant access control list or ACLs by using the grant RWS command to files and directories for multiple users or groups. You can use the following command: mount -o ACL directory, get facal, set facal, and so on. The file system includes support for access control list, which allows final grained control of the file's permission that are possible with the standard 3 access categories that are normally provided. Many file system commands such as copy, move, cp, and mv have been modified to copy the associated ACLs for a file. In order to enable ACLs on a file system, the file system must be mounted with the ACL mount option. The file system created using during installation include ACL flag in their default mount option, and you can remount using various options. The mount is used with the command, the first command, the mount -o ACL directory is used for mounting, and get FACL for getting the access control list. And you can also set access control list with set FACL command. Then there comes another topic that is very important, SE Linux implementation, the security enhanced Linux. They In an effort to deal with ever-increasing threat to the data systems, the US government assigned the National Security Agency, or NSA. This is the history for implementation of SE Linux. The US government assigned NSA with the task of developing a single set of rules that all other agencies would follow in handling confidential information. By evaluating previous breaches, the NSA determined that a major hurdle to securing data was internal users bypassing local security. In some cases, user would inadvertently open access to a system. A classic example would be a user executing the command chmod 777. It is a stupid idea to do that. You should provide only that particular permission to a user that is actually required. You should not provide all the permission, read, write, execute to anyone. That is a stupid idea. To the user, this may seem an easy way to allow co-workers to share files to prove his work less tedious, but that is a major security breach. They may not realize that this gives everyone in the world access to potentially confidential information. Anyone could access using the remote X, and various authentication modes. In more extreme cases, users would intentionally disable security for more insidious reasons. Both of these situations are example of user having discretion to control the access of their system. The NSA felt the solution was that having a system implement mandatory access control on MAC policy over the users. In MAC, a set of rules known as the policy identify what a process is allowed to do. Anything that is not explicitly permitted is by default denied. Ideally, different policies could be implemented depending upon how strict the security needs. Then the concept of type enforcement or DAC was there, which is a discretional access control. A rule set called the policy determines how strict the control. SE Linux implements a policy to uh, get rid of such users who provide all the permissions to everyone. The policy defines what resources restricted processors are allowed to access. Any action that is not explicitly allowed is by default denied. All files and process have a security context. The context has several elements depending on the security need, user role, and so on, usually paired with other options such as E minus E. The ls minus z, ps minus z is command to process a type of unconfirmed and restricted by SE Linux. To view the entire process stack, you can use ps minus ez and so on. The SE Linux could be used for targeted policy setting. The targeted policy is loaded at install time. Most local processes are confined. Principally, it uses the type element for type enforcement. The security context can be changed with chcon, the with command chcon minus t temp etc host. The safer way to use is restore con command by writing the restore con etc host directory. The SE Linux could be used for management purposes. The modes for enforcing permissive, disabled, changing enforcement, which is allowed in the targeted policies. The get enforce, set enforce command. You can disable the grub with SE Linux equals to 0 argument. You can even disable the grub. Just write SE Linux equals to 0, the grub will be disabled. In certain cases, you might need this thing if grub is proving to be a fatal security concern. You could configure the SE Linux on etc sysconfig directory. The system config security level is a graphical utility to change mode disabling requires a reboot. Similarly, for system config SE Linux for booleans and set troubleshoot to advices on how to avoid errors and not to ensure security. This was about user administration. We have learned about various security concerns, various facilities, the user ID, group ID, and a lot of things. We will be learning more in the coming videos. Till then, keep learning and keep moving ahead. We have learned about user administration in previous lecture, and here in this lecture we're going to learn about file system management. The file system management allows us to understand file system hierarchy. We have to manage virtual memory, add new drives and partitions, mount NFS file systems, and various other things. So let's start. Adding a new file system to the file system tree is simple. We have to do certain things in a process. We have to first identify a device, partition the device, make a file system, label the file system, create an entry in etc fs tab, and mount new file system. For recognizing a device, when a system boots, it searches for code that can start an operating system, which is made from a list of devices, CD-ROM, floppy, hard disk, as defined in the BIOS, the basic input-output system. The first executable code found is used. Most often, a system boots from the hard disk attached to the system mainboard or SSD, which is attached on a PC, and from the code found at the first sector of the first cylinder, the master boot record or MBR of the drive. This executable code is called bootloader. The bootloader starts your system. The basic bootloader begins maybe with a GRUB, the Grand Unified Bootloader. The space for partition table information includes the partition ID or type, a starting cylinder for partition, and number of cylinder for a partition. This is the way how a device is recognized. You don't need to do much thing other than BIOS. If you want to reboot, suppose you have two different operating system, Red Hat on your hard disk, the internal hard disk of your PC, and a Windows on a pen drive, bootable on a pen drive. Uh, with BIOS, you can select a boot order. If hard disk is preferenced as one, has a higher preference, and external USB devices are have lower preference, then when you have connected a pen drive and hard disk at the same time, the Red Hat will boot, which is located in hard disk. So this is the process of device recognition. You can manage uh, which device to be booting first, the bootloader to be loaded from that what device. Then there comes disk partitioning, which allows you to extend partition points to additional partition descriptors. Total maximum number of partitions supported by the kernel is 63 for IDE device drivers, integrated development environment for software development, 15 for SCSI drivers. Why partition drives? The containment, performance, quotas, recovery, they are used. The extended partitions and logical partitions are used. If one of the primary partition is marked as extended or type 0x5 with Windows 95 extended type 0xf, then the first sector of the partition described by the entry will contain another block of partition descriptors. These descriptors define partition known as logical partitions. Use of logical partitions is a workaround for limitation in the legacy. MS-DOS based partition table structure and the logical partition permits the definition of more than 4 partitions for drive, while the PC partition specification does not impose a limit to the number of logical partitions. Uh, suppose you have partition for swap, uh, MNT mount, and root we have configured when installed Red Hat. In the second video of essentials, the installation. So similarly, you can partition your disk. You can manage partitions with two commands, fdisk and sfdisk. The GNU parted which is an advanced partition manipulation to create, copy, resize, etc. You can also use part probe that reinitiates the kernel's in-memory version of the partition table. The partition table stores the partition. Actually, partition is nothing. In reality, that do not exist on physical level. It is a logical partition or virtual partition just for to accommodate users, facilitate for a better use. The folder we have learned about the directory table, and here it is a partition table. You can also create your own file system or a new file system by using the command mkfs. Uh, if you want to create a file system with ext2 file system standards, you have to write mkfs.ext2. If you want to create a partition with for ext3, you have to write with the .ext3, or for MS-DOS, you have to write MS-DOS, and so on. Specific file system utilities can be called directly using mke2fs, provide option and device. The file system labels are alternate ways to refer to a device. Uh, Labels are similar to alias, but they are different from alias. They are device independent. E2 label, special device could be used, and so on. BLK ID can be used to see labels and file system types of all devices. Then there comes another function that is called tune2fs. It adjusts file system parameters, the reserved blocks, default mount options, FSCK frequency. You can view current settings with a dump E2FS. It is used to modify the percentage of reserved blocks. The reserved blocks, the value lower than 5% can lead to performance degradation due to fragmentation. You can create fragmentation as well. The command is used as a tune to fs minus m, provide parameters and a location. The mounting points can be configured with fs tab in etc directory. The configuration of the file system hierarchy is stored with a mount points. It is used by mount, FSCK, and other programs. It maintains the hierarchy between system reboots. It may use file system volume labels in device fields. The mount -a command can be used to mount all file systems listed in etc fstab. Mounting file system with the mount command. A new file system could be mounted, like if you place a pen drive with different file system on a system on your desktop or PC with a different file system, it needs to be mounted on the tree of your system PC's file system. The file system on a pen drive get mounted on a PC's file system at a particular location that you define. Using the mount command, you can mount a device on. Minus T argument is used, not normally used, and minus O options are there. The default options for the mounting a file is are RW, SUID, dev, EXEC, ACL, and async. You can also unmount a file system from your system by using the unmount command and provide the mounting point and the device name. You cannot unmount a file system that is in current use. You can use the fuser to check and kill processes running on different file systems. You can use the remount option to change a mounted file system's options atomically using mount -o remount or arrow. You can mount a sample file system requirements met using options. You should disable executing access, mounting a file system image, mount a PC compatible file system, disable access time updates, and set up mount aliases. This could be done with mounting options. Then there comes a handling of swap files and partitions. The swap space is a supplement to a system RAM. It is very vital. You should create swap partitions with some useful considerable amount of space. It is used as a supplement to system RAM when your RAM size is not enough to for a particular computation. The swap space is used for that thing. The basic setup involves by creating a swap partition of file, writing a special signature using MKS swap. You can add appropriate entries to etc fstab and activate swap space with swap on -a command. You can now mount NFS file systems that is used in modern day USB drives. You can make a remote NFS file system work as though it were a local file system. It can be used to specify persistent network mounts. NFS shares are mounted at boot time. The exports can be mounted manually with the mount command mkdir make a directory and mount it on the location using the NFS argument provided by -t argument. You can also use a auto mounter where system administrator specifies mount points controlled by auto mounter daemon process located in auto.master. The auto mounter monitors access to these directories and mount the file system on demand. It can mount automatically. It is generally a graphical utility. The file systems automatically unmounted after a specified interval of inactivity. To enable a special map, you can use a -host or browse all NFS exports on the network. It supports wildcard directory names as well. You can also use direct maps. Direct map includes absolute path name. It does not obscure local directory structure. This is an example for a direct map. Direct maps can be used to automatically mount a file system to any mount point in the file system. A direct map contains absolute path as defined in auto.master again. Only rightmost directory is put under auto mounter control. Thus, the directory structure above the mount point is not obscured by AutoFS. Then there is a genome mount option that automatically mounts removable drive devices. It is integrated with hardware abstraction layer. It replaces fstab sync. Uh, Genome mount is a simple thing. You don't need to write a mount command. This is an option for simple users, specifically for desktop version users of Red Hat who are not concerned about the server environment and they don't want to write mount commands every time. They are not high-end users. They simply want to place the device, place the pen drive, want the pen drive to show up and they can so that they can copy or move files from system and pen drive and vice versa. So this was a brief introduction, a brief learning about file systems. We will be learning more in the coming videos. Till then, keep learning and keep moving ahead. Welcome back, friends. In the last video, we have learned about file system, the advanced file system, and here we are going to learn more about file system in depth. So let's start. Here we are going to learn about the file system quotas, how we can set up the file system quotas, manage software RAID devices, configure logical volumes, set up LVM snapshots, the logical virtual machine, and the perform backups, and so on. So let us begin with the quota system. Let us understand what a quota system is. So Linux quota system allows an administrator to establish limits on the amount of disk storages or disk resources users can consume. Because a resource accounting must occur with every file creation, quotas are implemented within the kernel. Various required quota administration utilities are found within the quota RPM. We have to configure the quota system, which is implemented within the kernel. It is enabled on the per file system basis. The individual policies for groups and users are there. It limits by the number of blocks or inodes. Inodes the table for file directory, the system. It implements both soft and hard limits. The initialization consists of partition amount options, the USR quota and user group quota, the GRP quota, group quota, initialize database with quota check. You can use these commands to create a user quota, group quota, and check quota initial database. Then there comes setting quotas for the users. It is implemented at start or stop quotas. You can start with quota on or stop with quota off option. You can edit quotas directly by ed quota username. From a shell, from Linux shell or terminal, you can write the set quota, provide a username, and set the file size permission, the size you want to give, and a directory. Then you can define prototypical users for with a ed quota. You can edit and copy the same thing for multiple users. You can report quota status with three options. The user inspection could be followed by the quota command. Quota overviews could be done with REP quota, and the miscellaneous utilities could be monitored with a warn quota. So here comes another concept after quota, when we can use a quota, which is very useful for DBA, database administrator. And now we are going to explore about RAID, the concept of RAID. Uh, when either partitions or a whole disk which can be used to create a software devices, the RAID is used. The term disk is used here to denote either a whole disk or a partition, one or more disks. Though it's possible to create an array composed entirely of partitions on a single device. RAID is actually multiple disks grouped together into arrays to provide better performance, redundancy, generally both. So MDADM is an option that provides the administration reference interface to software RAID. There are different RAID levels based on different classes. The RAID 0, RAID 1, RAID 2, RAID 3, RAID 4, RAID 5, and so on. So RAID 0, which is called stripping mode. RAID 1 is called mirroring mode, and RAID 5, which is a unit of 3 or more disks with 0 or more hard disk pairs, it is there. You can understand RAID in a depth. Once an array is created, its device inside the div. For example, it is used the same way as SDA6 or SDA6, which may have been used in the examples. Spare disks add extra redundancies, and RAID devices are named as MD0, MD1, 2, 3, and so on. Software RAID configuration is used to create and define RAID devices using MDADM command. You can use that thing. You can format each RAID device with a file system by writing the command mke2fs. Make e2fs command with a -j option and provide the MD0 directory in the div. You can test RAID device. MDADM command would allow you to check the status of your RAID devices, whether they are configured properly or not. Anything else? The software rate testing and recovery option is very useful. It simulates disk failures. It helps you simulate when real disk failure occurs. You have left with no option. If you have not learned by simulating the failures, you can simulate disk failures and check how we can recover from it. Recovering from a software rate disk failure replaces the failed hardware drive and powers on. Reconstruct partitions on the replacement drive, and the command syslog, mdstat, mdadm could be used to test and recover rate disk failure. Then there comes another topic that is called LVM, or Logical Volume Manager. It creates LVM creates a LVM is actually a layer of abstraction that allows easy manipulation of volumes, including resizing of the file system. Basically, it creates a higher level layer of abstraction than traditional Linux disks and partitions. It allows for greater flexibility in allocating storage. Logical volumes can be resized and moved between physical devices easily. The physical devices can be added and removed with relative ease. LVM managed volumes can also have sensible names like a database or home, rather than somewhat cryptic SDA or SDA device names. It allows reorganization of file system across multiple physical devices. It does not actually exist, but it is a logical unit. You can configure it as per your use. These devices are designated as physical volumes. One or more physical volumes are used to create a volume group. The volume groups are defined with physical extents of a file size, fixed size. Logical volumes are created on physical volumes and are composed of physical extents. The physical volumes are real hardware storage, the cylinders, the cones, that combination. And the logical volumes is simply the directory, file system, and whatever you see. The file system will be created on logical volumes. This is a simple hierarchy of logical volumes. The logical volume is consisting of a volume group. The volume group consisting of physical volumes, and physical volumes is Linux partitions. We have commands for upgrading the LVMs. You can resize the layer of abstraction is there. The PV create moves from Linux partition to physical volume. The VG create from creation of volume group, and LV create for creation of logical volumes. You can create logical volume by using the command PV create to create a physical volume. Uh, you can assign physical volumes to volume group. Then you need to create a logical volumes from volume group. This is a syntax. Remember from this previous diagram, we have to first create Linux partitions, then we have to create physical volumes. When physical volumes are being created, we have to create volume groups, and after these three have been created, we have to create logical volume at last. So the process of creation would be from first we have to execute pv create command, then vg create, then lv create. This is the process. After we have executed the lv create command, we have to execute the mke2fs, the file system. It will create a logical volume. We have to pass argument based on our location, desired location. The LV create argument takes the size of the logical volume. Suppose we have given 256 MB written by 256 capital M. You can also resize logical volumes after you have created. You can grow volumes. The LV extend can grow logical volumes. It is used to increase the size of the logical volumes. Resize 2FS can grow ext3 file systems online. VG extend command adds new physical volumes to an existing volume group. You can similarly shrink volumes, reduce the size of the file system. or logical volumes, the file system must be reduced first. Before reducing the size of logical volumes, you have to reduce the size of file system. It requires a file system check and cannot be performed online. The LV reduce can then be used to reduce the volume after we have configured these things. The volume groups can be reduced with a pv move command and execution of vg reduce command after that on the same directory. Then there comes a logical volume manager snapshots. Snapshots, which are special logical volumes that are an exact copy of an existing local volume at the time the snapshot is being created. Snapshots are perfect for backup. Snapshots are actually your current state, the configuration of everything on your system. It takes similar to a snapshot, whatever that thing. It is really a backup of live data. It is important that when taking a backup that the data sets in question do not change while the backup is in progress. It can lead to inconsistency and data loss. You have to take backup. Uh, when a snapshot is taken, it takes a static copy of the data from the live data set which is available. This can be used to make a backup. So the difference between the live backup and a snapshot is we have to create a snapshot when we want to perform recovery operations. A temporary copy of an existing data set is needed. Snapshots only consume space where they are different from the original logical volumes. They do not create redundant data, only the unique data. You can use LVM snapshots to create a logical volume from logical volumes. You can create a snapshot of logical volume by LV create command and execute a minus S argument for a snapshot. You can mount a snapshot on a directory, create an mkdir, write an mkdir command and pass the minus P argument and mount a snapshot by writing the mount command afterwards. You can remove a snapshot by unmounting and executing the lv remove command. Then there comes another useful utility that is called for archiving tools, tar. Suppose we have a thousand of files contained in a directory and the size is actually very large. For suppose we have 1 GB size and we want to transfer those files in a single as a single file with a reduced size. We have to compress or archive those files. A tool that is used for archiving those files is tar. We have to create a tar ball of those 1,000 files. A tar can back up to a file or tape device. It supports gzip or GNU zip and bzip to compressions. It can preserve file permissions, ownership and timestamps. It supports extended attributes. It uses RMT to write to a remote tape device. You can also add a username password for archiving for those to access the file. Archiving tools, there are tools like dump and restore to backup and restore the file system, which does not work with other file systems. Dump should only be used on unmounted file systems or file systems that are read-only. You can do full or incremental backups with dump and restore command executed in a sequence. Then there comes another archiving tool that is called rsync. It efficiently creates copies of files to or from remote systems. It is used for remote system. The tar was used on the same device. It is used on remote systems. It uses secure SSH connection for transportation. The command for executing this thing is rsync asterisk dot configuration, name of a file dot configuration, provide the location for the file, and so on. It is faster than SCP. It copies differences in like files. So this was about advanced in-depth about file system. We have learned various things. Give it a look. Try executing certain commands, create your tar files, run remote archiving, and other things. We will learning more in the coming videos. So keep learning and keep moving ahead. Welcome back, friends. In the previous lectures, we have learned about file system management, and now in this lecture, we are going to learn about network interfaces. So let's start. Here we are going to learn about configuring IP interfaces, the Internet Protocol, set up routes, understand name resolutions, and set up IP version 6, and more topics. So let us start with network interfaces. The logical network naming, display hardware configurations, these are part of network interfaces. Networking scripts refer to logical interfaces here. And the logical interfaces are Ethernet, dial-up, loopback. The Ethernet connection is represented with ETH0, ETH1, and so on. The dial-up is represented with PPP, point-to-point protocol, 0, PPP1, and so on. The loopback is represented with LO. So we must understand what are the representation of the logical reference of different networking appliances. So these are here. The display in network interfaces by using ifconfig to show the current IP address of our system, Ethernet or dial-up or loopback details and so on. We can do so with ifconfig minus A, the complete detail. If you don't want to show the complete detail, you should omit minus A argument just to display IP address and subnet mask. IP link, IP space link is used to display IP related information and again more information regarding Ethernet and so. Then there comes our driver selection. There are different device drivers and other drivers on a system that could be also influenced with a network driver. Uh, all drivers for a network interface cards are built as modules. They are referred as modules. Um, the configuration file for mod probe that maps logical names to specific modules could be done with aliases. The alias ETH0 and the file directory name could be used. The secondary card selection can be specified in the interface configuration file, which is located in etc sysconfig network scripts. If cf get etc0, here we can create variable for the IP address. Here the 000D, this is the format of IP version 6. We can define it in the variables. The kernel modules for easy adaptability to any hardware configuration is compiled using Red Hat network card drivers. The network interfaces modules are loaded at boot time if networking has been enabled. When we have installed our operating system, the Red Hat Enterprise Linux, we have enabled the network drivers. So we can do network connection, establish network connection. The appropriate module is loaded based on the aliasing in the mod probe configuration that we have learned. We can speed and duplex settings. Go to speed and duplex settings. The network cards can negotiate speeds and duplex settings with the hub switch that they are attached to. The auto negotiations allows the network card and upstream hub switch to transparently select the optimal setting. When there is a mismatch in speed and or duplex between the settings presumed by the card and the settings presumed by the upstream hub switch, the communication becomes intermittent at best or non-existent. A mismatch will also exhibit error statistics when viewing the interface through ifconfig or slink. So the mismatch can cause intermittent or no communication, and which could be managed by speed and duplex settings. We can change the speed of our network and different things. The manual overridden could be done by using ETS tool. ETS tool opts and options to install the mod probe configuration for older interface modules. We can also display IP version 4 addresses by using ifconfig as you learned, or IP address. Sure. And similarly, we can configure also. It does not simply displays us. We can set our IP address, the static or dynamic. The dynamic IP configuration is wider than static. Uh, the static IP address is simply the constant for over the time. You may need to purchase that static IP. A dynamic IP could change over time. The interface configuration is defined in the dynamic, the etc directory again. The dynamic with line of boot proto equals to DHCP, dynamic host control protocol. Zero configuration of networking is used with 169.254.0.0 with 16. We have to configure the host and network sections of the IP. If you're good in networking, you would understand what I'm talking about, the subnet mask and these things, the class A, B, C, D. These are the terms that are used in IP address configuration. You can disable the lines and so on. You can use a if down device, if up device up to apply configuration changes. Static IP version 4 configuration could be done with ifcf get gethx. Static with lines of boot proto equals to none, IP address equals to 10.0.0.1, and network mask, the subnet mask is equals to 255.255.255.0 for IP version 4. The device aliasing could be done, which is useful for virtual hosting. A common is configuration is to host multiple web or FTP sites on a single server, which is also called as a virtual hosting. It separates IP address or separate IP address is generally required for each website that supports SSL or when defining multiple FTP sites, the file transfer protocol. Device aliases are virtual network interfaces that can be configured with an additional layer 3 network address. The name of the device alias takes the logical adapter name, appending a colon and unique number representing the alias. You can bind multiple IP address to a single NIC network interface card with virtual hosting like ETH1 colon 1 2 3 so on. You can create separate interface configuration file for each device aliases with ifconfig command. Ifconfig. You must use static networking for device aliasing. Similarly, you can use the routing table for routing for finding the route of data packets that are transferred over the network. Defines path to all the systems of the data table. You can use the route route command, net stat -r command, IP route command, and so on. The default gateway could be configured when no route entry is matched. It might be obtained dynamically with DHCP, Dynamic Host Control Protocol. It can be statically configured with the line of gateway equals to provide an IP address here. Globally in the etc directory again, the sysconfig and network. Or you can also use the POR interface in the interface configuration file that is located in uh, system config in ifcf get thx. file. You can configure routes to control traffic flow when there is more than one router. Similarly, when there are more routers and more devices in a network, specifically in a LAN, local area network, you have a wide range of data packets flowing here and there. It could be connected over an internet, and you can control those routers and configure them via an operating system. The static routes defined per interface is there, route ETHX. It uses IP route as syntax. The dynamic routes are learned via daemons. The Quagga, the support for various forms of RIP, OSPF, and BGP. You can verify IP connectivity by using the ping command. Suppose we want to verify whether the google.com is being up and showing up the connection. We can write ping space www.google.com. Our computer tries to establish a connection with google.com. When it responds with a response, hi there, I am Google, I am ready to connect it with you, the handshake in networks terminology. Your computer will show different lines of code executing one by one, splashing on your screen. Then your computer is being connected to the Google server. The ping command is used to verify app connectivity. Network packet loss and latency management tool could be used with traceroute. The traceroute allows you to monitor packet loss and latency, the latency of transferring the packet from source to destination, time latency, and other things. If you want to display network path to a destination, you can use MTR utility. Similarly, you can define the local host name by viewing and setting local host name with host name initially defined in the etc sysconfig networks. You do so by defining it in a variable, the host name, and provide them the host name. You might pull name from a network, the DS client daemon. You can reverse DNS lookup. The local resolver could be used. The resolver performs forward and reverse lookups. The local database of host name or IP address mapping could be used in etc hosting. It is useful for small isolated networks. Normally it is checked before DNS. Then there comes remote resolvers. They are different from local resolvers. They are used to the domains to search. They perform. It is can be configured with a resolve.configure file, which is located in etc directory, and it follows a strict order of name servers to use. It may be updated by DSC client. NSS switch configuration file is used for precedence of DNS versus a host file. The difference between localhost and remote resolvers, local resolver and remote resolver could be understand that whether a user will want to refer to the system by name, the system needs to convert those names into corresponding IP address. The local resolver does so. It resolves of the number when we have the name forward lookup or when we have a number for reverse lookup. Similarly, the remote resolvers would allow you to for distributed administration of the names defined in the internet. The follow general conventions, placing them a tree-like hierarchy known as a DNS, and so on. The DNS connectivity uses NS lookup, which is depreciated, not used these days, the host and the utilities commands. The network configuration utilities could be done with system config network, which is a GUI utility where you can monitor these things. The profile selection, system config network, CMD, net profile kernel argument could be used here. You can use transparent dynamic configuration using the NM applet. It is used to list of profiles managed through this thing. The network manager service coupled with the user space tool is more fully integrated with configuration of the network. As you disconnect your laptop from the wired connection in your cube or on the way to the conference room, the network manager service transparently switches you from your wired configuration over your wireless adapter. When you take that first trip to the coffee shop on main and boot your laptop, you interact with NM applet, that is network manager service, to specify the wireless settings, the wireless network and security key which will be automatically remembered for your next trip. This is the use of transparent dynamic configuration. The NM applet could be configured. You can implement IP version 6, the secure authentication rather than IP version 4. It is used with HTTPS. The kernel IP version 6 module enables stateless configuration. You can follow additional configuration implemented here in the initialization script as here. You have to define in the variable networking IPv4, v6 and IPv6 init. Yes, the IPv6 or version 6 is configuration can be dynamically configured by using the router advertisement daemon or DHCP version 6. The router advertisement daemon runs on Linux, the default gateway with a RADVD. It only specifies prefix and default gateway. It is used to enable with IP version 6 auto configuration. You have to define these variables as yes. The interface ID, which is automatically generated based on the MAC address, the physical address of your system, or DHCP. It supports more configuration and so on. You can move with further configuration. It's not very difficult thing. The static interface configuration could be followed up here in this path. The routing configuration could be handled by default gateway or the static routes. The default gateway, which can be dynamically from RADVD or dynamic host, IP version 6. The manual specification could be found in the network category. The static route is defined per interface here. It uses IP version 6 route to add syntax. You can configure IP version 6 for static, dynamic, and DHCP client, the routing table, and everything on the network. You can add new modified utilities with ping 6, traceroute, and so on. The version name 6 or 7 or 8, anything. So this was about networking on RHGL. We can configure our IP address, MAC address, all the device, Ethernet, the dial-up, and various other connections. We can even configure the routing table, the router, and everything else. We can decide how our data packets flow over the network, how a system loads up, as our server in a data center is itself uh, a system where a website is supposed to be loaded or data has to be there, we have to configure static or a different IP address. All these things, the network part, the database part, and the Linux part, are not to be conducted by a same person in every organization, but having idea of each category with not very expert level, not basic level, would allow you to master your job. You must be aware of all the things. The choice is yours. You can go with any of the things. Uh, and if you are preparing for the certifications, these things could be asked. Some things, not every file would be asked, but things could be simple, more simple than you may think. So keep learning and keep moving ahead. We will be learning more in the coming videos. Welcome back, friends. We have learned about system administration. We are learning system administration. We've learned about kernel services, system services, user administration, advanced file system, and much more topics, including networking. And here in this lecture, we are going to learn about installation. Traditionally, thought installation is a simple task, but not actually as simple as Windows. In Windows, Linux has a proper or somewhat called difficult installation procedures because here we have more intuitive approach over installations. So installations on the Linux environment, specifically Red Hat, it has a great concern and we can control over various factors. So the installation on RHEL is governed as a separate topic. It has equal weightage. So we are going to learn about it in depth in this lecture. So let's start. Here we will be learning about important command line switches, understand different installation methods, create advanced partitions layout, and understand the Kickstart's role. Kickstart we will be learning about in detail, uh, Anaconda and other things. So let us start our journey with Anaconda. It is a Red Hat Enterprise Linux installer. Anaconda is the installer for RHEL. It is a Python-based program feature having several modes. The Kickstart mode provides an automated installation, which is discussed here. It has upgrade mode, rescue mode, and Anaconda runs in two stages. It supports different mode. The Kickstart is an automated installation of Anaconda. You can upgrade the performs an update of an existing Red Hat Enterprise installation. The rescue mode allows you troubleshooting of the unbootable systems. Sometimes the bootloader of a system crashes for a wide range of reasons, and you are uh, entrapped with uh, unable to log into your system. So, what you can do, how you can rescue your system, Anaconda would help you out. It consists of two stages. The first stage starts the installation, and the second stage performs the installation. The two modes of Anaconda are upgrade and rescue mode. The upgrade mode can be selected when the installer detects an existing RHEL installation. It upgrades existing packages and leaves configuration and other user data intact. Then there comes a rescue mode, which can be used to troubleshoot a system that is no longer bootable. It loads the necessary rescue environment from the second stage and gives the user a shell to access the system. And the virtual console or command line interface of the Linux terminal would be provided to you to access the system. The reasons for crash could be suppose you have updated your system with a "-f" or "-u" option of freshen or upgrade your Linux kernel image, and the new kernel image proves to be unstable, and for somewhat reason it crashes down. So you are left with no kernel other than newer version because you have automatically deleted the earlier version, and your system crashes down. You can use the rescue mode of Anaconda to gain re-access of your system. The first stage is the starting of the installation. It consists of installation of the kernel and init rd, init RAM drive dot image, the .img file. It can be started by any supported bootloader like grub, Grand Unified Bootloader, the Linux bootloader, and so on. The task of the first stage is to initialize the installer. It parses the command line arguments. Parsing means if you have learned about compiler design, there are tokens, parsers, uh, the syntactical analysis phase, the parsing phase of detection of a programming language or commands. The parsing is done with this stage. It auto detects the hardware. It loads additional drivers. It allows you to select language, keyboard layout, and installation method. It sets up networking if required for the installation. The first stage is with boot media, where you boot the CD or DVD drives. The boot.iso or installation of the CD DVD is done here. A USB drive containing boot image.img, a network boot with a PXE, other bootloaders such as grub, boot floppies that are not any longer supported. The boot media can be modified for custom installations. Then there comes accessing the installer. This phase, you have to gain the access to the installer. The graphical installation, if you're doing with a graphical installation, you have a better compatibility or better user interface. However, you have a restricted control over the things. It is a default installation type because most users could not use the command line and advanced features. It has useful switches like low resolution, escape DDC, and so on. The VNC based installation consists of activate with VNC and protect the session with VNC password, provide a password in the VNC password variable. Similarly, you can set network parameters with IP address, the net mask, the network mask or subnet mask, the text-based installation, which is the command line interface, has to do with the text switch. It has a menu-based terminal interface. You have to select from certain options available in the menu. Then there is a serial installation which uses automatically when new graphic card is inserted. It is enabled with providing the argument device equals to serial. Then there comes the first stage where we are learning the installation method, how it is conducted. The available installation methods include the CD-ROM, how you can install or boot your system, the physical drives. You can install with a CD, DVD, a hard disk, external hard disk or internal hard disk, an NFS image, uh, an FTP client over the network. You can also boot from the network by pressing the LAN wire or Wi-Fi, or you can also do so with over the HTTP protocol of the internet. It has the media sets. The two sets are available as client and server. The client and server are available here. It can be downloaded from RHEL Red Hat network page, which may contain packages for additional layered protocol products. The installation key should be entered to unlock additional content. That is not a problem. You can also boot with a ext2 image or the ISO image from the USB drives or NFS media and so on. Then there is a network installation server which is used with NFS or FTP. It is often faster than as compared to CD-ROM based or a hard disk based installation. It is necessary for network based installs. Suppose you have network installations, a distributed environment or over a lab or a server environment running in a LAN. It allows you to share the Red Hat directory via NFS or FTP. You have a better flexibility over the environment, the security, and other concerns. It can be used as a yum repository, which is a default installation media for installing various utilities and softwares. Then there comes a second stage, that is installation overview. Here you have an option to select a language, a keyboard selection, date and time selection, disk partitioning, bootloader configuration, network and time zone configuration, package selection. You have to provide the installation key. The swap partitions could be used, any partition, whatever you are doing so. You have to create the swap partition. All we have covered in the second lecture of the installation of the RHEL image. But these are the options that you might have not given focus or concern in depth. Here comes the configuring of file system, the second stage. You must select mount points, the mounting that we have done in the previous lectures. The mounting points, the partition size, we have to define partition for swap, root, and other kind of partitions, etc. You have to create partitions and the file system types in the installer. You can manually or automatic, you can manually set up, or it may automatically select the file system by default ext3 or ext2 or any other partition. The DOS partition currently don't run on RHEL, but you can choose that file system to be there. There are many layouts which may be used. Root must include the directory like etc, lib, bin, sbin, and so on. There is a huge range of libraries. We have already learned in essential sections the complete Linux file system that is there. The swap spaces are typically is a multiplication of two of the physical RAM. Suppose you have a RAM size of 4 GB, you must create a swap memory of size 8 GB. Swap is also used as an additional support to RAM. It is a benefit in Linux. It is absent in Windows environment. Uh, Here the swap implementation is useful when suppose you have a files or a program which is running on your environment and it requires a RAM of 16 GB and you have only 8 GB of RAM. So by having the swap partition of 16 GB, the double of your RAM size, you could run 8 plus 16 size. It is not as fast as RAM, but it is an additional. Actually, the difference between RAM and hard disk is simple. Hard disk or SSD is slow as compared to RAM. The read-write operations per second or at a particular moment of time is very fast, very rapid in RAM as compared to the hard disk or SSD. The data is meant to be stored on hard disk or SSD, but on RAM it has to be copied and removed. It has to be converted every time. So a swap partition is a part of SSD or hard disk, and you have designed it to be used as with RAM. The typical mount points are boot, where you mount your pen drive or other file systems on the native Linux file system. The home, user, var, temp, the temporary, user local. This is a local location for a particular user. Uh, for non-root users specifically, and option and other file systems or other directories. Then there comes advanced partitionings. RAID is the software RAID or LVM could be advanced partitioning. The RAID allows you to create new partitions and select software RAID as a file system type. You have to combine RAID partitions into RAID devices with RAID. We have learned about RAID in the network sections. Uh, then there comes LVM. We select the physical volume, the virtual manager, logical virtual manager memory to create physical volumes. LVM creates a volume group. It adds creating logical volumes. We have to create a first a physical volume, then logical volume has been created. We have already learned about this. Then there comes a package selection. The default set of packages is automatically installed. You can select customize now to change the default set of packages. The customizing is necessary to add support for additional languages. Suppose you have default language of English, Spanish, French, Russian, and so if you are a speaker of Esperanto, which is absent, or if you could be a speaker of Zulu, the African language, you could be installing that package separately. Yes, of course, you can have any language as an option displaying in the GUI modes. You can install that thing. Anaconda automatically resolves package dependencies. You have to provide them. The package set can be easily customized after install with yum or system config packages. The yum is a command line utility which allows you to install, upgrade, manage, delete any packages or any repositories or softwares. Or if you are not familiar with yum and not comfortable, specifically for desktop users, not very advanced users, they could go with system config packages. which is similar to Windows add or remove software. The program features, you can have a graphical a view where you have to click, select, and do so by pressing the next or other options. Then there comes the booting, the first boot, the post install configuration. Here we have to configure X Windows system if necessary. Actually, it is not preferred over the server environment where your company's entire data, or including the website, is being hosted on a server. That is, it is not preferred to have a GUI mode, X window. You should disable X window because having a GUI mode itself is a risky thing because you may be in very comfort and do not know what is actually happening. There is various concerns. It adds an extra load over the environment and so on. Or if you are having an IoT devices like Raspberry Pi or other devices, installing a GUI mode is very heavy weighted for smaller devices. You should run with very small lines of code. The power of Linux kernel is that it could be installed on very small devices, as small as a mobile phone, any devices with a very small size, and you can go with that. The command line interface is itself very powerful. It has a very high versatility, and you have to be aware of various utilities and commands options available there. If you have to configure X window, you can install the KDE or GNOME. The GNOME is default with Red Hat. You have to install the complete server packages. Otherwise, it is. If you choose to be a light package of RHEL, it does not provide you X Windows configuration. You can add firewall and SE Linux setup, key dump setting, date and time, register with a Red Hat network to get updated RPMs. You can have set up users, different users. You can create and remove. You can configure sound card, install RPMs, and Red Hat documentation from CD-ROM. All these options are already available in the virtual consoles, the command line interface. Then there comes a Kickstart, which is an option. Uh, it has a scripted installation method. The Kickstart allows you to install to read allows the installer to read information from designated file rather than prompting the person doing the installation for it. It especially facilitates the setup of a number of machines that have similar hardware that the installer can auto-probe successfully. If it requires an item to omit from the Kickstart file, the installation part pauses and the user is prompted for the information. It covers the scripted information. It supports all Anaconda features. The root slash Anaconda KS configuration file is automatically created during installation. The configuration is utility is available in the GUI mode as well. A system config kickstart could be found on application of the desktop of RHEL. A system checker with a KS validator could be used for Kickstarter, which is a syntax checker. You can start a Kickstart installation where Anaconda enters the Kickstart mode when the KS boot option is specified. The KS queries DSCP Dynamic Host Control Protocol for the Kickstart location. You have to define the variable URL equals to KS. It gets the file via HTTP, FTP, or NFS. From the local medium, you can also select floppy, CD-ROM, or other devices, including the hard disk, and provide the path for the file, the image. Then there comes anatomy of the Kickstart file, the command section, the package section, the script section. The Kickstart file consists of several sections. In the first section, the system is configured. If one of the mandatory directives is omitted, Anaconda will automatically prompt the user. After that, it continues with Kickstart. The package section, the command section, and the script section. The command section configures the system. It is omitted. The package section selects the packages and group for installation. It checks the dependencies, which are always resolved. The script sections have contained the options section to customize the system. It has a pre and post option, which are the scripts that are run before and after the installation. The pre is learned executed before installation, and the post scripts are executed after installation. The kickstart having the command section starting the installation. Installation mode consists of install and upgrade. Install performs a fresh install. Upgrade performs an existing installation. Installation method include CD-ROM, URL, NFS, hard disk. The way you have to define your things. The command section, which is important, which have important directives. The required directives are with localization options, the authentication, the bootloader. It must be specified, otherwise the installer configures them interactively. The localization options including keyboard, language, time zone uh, as your local location. The authentication, root, password, authentication configuration, and other things have to be defined. The bootloader has to be defined. It has optional directives like network security and installer behavior. The security concerns the firewall, SE/Linux services, and other. Here we have package selections. You can add package groups with a @package group. To remove a package from the list, you have minus package name. You can use wildcards to specify multiple packages. Dependencies are always resolved. The support for additional language could be started with @language support. The kickstart pre and post scripts. The pre gives you the first word. It executes as a bash shell script. It is executed after kickstart file is passed. The post script gives you the final word. It is after the installation is over. It can specify the interpreter. Actually, bash shell is or Linux terminal is an interpreter where you execute one line at a time. The ch rooted by default, but may be run without chroot. So this was about installation. We have learned about various options with installation, the Kickstart, Anaconda, and various mode. Um, we can go with them. The installation looks simple, but it has various options. It is not very difficult either. But having a proper knowledge about what the options are there available at the installation time and what you can upgrade it later, uh, you can perfectly select your system is configure your system as per your requirement. The requirement may vary. The Red Hat is also meant for a huge, huge enterprise solutions and a small desktop edition as well. You have to configure it according to your usage. It is a software which can run on a wide range of hardware configurations. You have to choose it according to your need. Uh, we will be learning more in the coming videos. Till then, keep learning and keep moving ahead. Welcome back, friends. Finally, we have reached our destination and a very interesting topic of virtualization. Virtualization on Red Hat is implemented with Xen. Here in this lecture, we are going to learn Xen virtualization. We will be learning virtualization, what is virtualization, understand how Xen is being implemented, and learn to use a few tools of Xen. So let's start. Virtualization with Xen is implemented. The goal of virtualization. Let us, before understanding Xen, we have to first understand what is virtualization and how it is being implemented and what is the requirement of virtualization. Most of you may have used a tool like VMware desktop implementation. Using this software, you could run different images of operating system simultaneously on a host operating system. Suppose you have a Windows or Mac or Linux environment. Suppose we have a Windows environment on our system and we want to use Red Hat. Simply put, we don't need to format a system or make it a dual boot. we can install a VMware application, and where we can provide a Red Hat image or Ubuntu image or Kali Linux image and install them simultaneously on our system. We are running two operating systems at the same time, one in virtual mode, one in actual mode. So the virtualization could be more powerful than that. It could isolate different process, typically suspicious, or it is also implementation of sandboxing, which is a running of malicious, or sorry, not malicious actually, suspicious code, which is executed in the sandbox. If it is it works properly or according to us, it serves our solution. We will be running it in the real mode. Otherwise, we would classify it as a malicious thing. It is a way how most antiviruses work and define viruses, the threats. Virtualization is a very important thing for testing and other purposes. On the cloud also, AMI, the Amazon image, is implemented with Zen. The virtualization is being implemented with Zen. So what is virtualization? The goal of virtualization is usually more effective use of resources. Basically, the resources should be effectively used as much as possible by using multiple operating systems on the same device and much more things. Projects may require a dedicated operating system installation, but not an entire dedicated computer. Simply put, you need a Linux as well as Windows on the same system, but though both two devices operating systems should not necessarily be installed on different physical devices. They can be installed on the same device. Virtualization has many additional advantages as well. It can greatly simplify provisioning while adding flexibility at the same time. You can use anything. The advanced users of Zen support features including moving a live running instance of an operating system from one physical computer to another. It is very important task that is unique to Zen. Such a live migration typically incurs no more than 10 millisecond delay. It is very fast. Individual virtual machines are completely separated by the hypervisor. We will be learning about hypervisor. Uh, that can only communicate over the network if permitted. You have to set permissions for this, and intrusion in one domain does not affect other virtual machines. So again, it is safe. As I have explained you about sandboxing of antiviruses, even the browser, typical browsers, Chrome, Firefox, Safari, they implement the concept of sandboxing. These JavaScript are generally being executed on sandbox. They could do not much harm on your system. Let us understand what the two concepts, the hypervisor and domain means, uh, the key concepts of Zen. The hypervisor is the manager of the Zen environment. It acts as a traffic cop or a policeman, traffic officer for all virtualized operating systems, controlling and provisioning access to resources such as storage, CPU, and memory. Additionally, the hypervisor controls migration, starting, stopping, and pausing the virtualized operating systems. It is started by the bootloader, uh, and there comes a domain. Domain is a Zen term for the virtual machine. Hypervisor controls various machines, which is called as domain, in which a virtualized operating system executes. In the world of Zen, a domain does not exist until it is created. Usually, to start up or install a virtualized operating system, domain 0 is privileged domain that controls the hypervisor. All other domains are called as domain U, which is a special term. So domain 0 and domain U are two kinds of domains for Zen. Then there are two types of virtualizations implemented with Zen, the para virtualization and full virtualization. The para virtualization is a native mode of Zen in which virtualized operating systems include support for Zen environment as if it were a variety of x86 architecture CPU. The main advantage of this approach is performance. Virtualized operating systems are running in this mode typically incur no more than 5% performance as compared to bare hardware. The prior virtualization is a not complete virtualization over the environment. Then there comes a full virtualization, uh, where Zen provides a complete machine simulation to run operating systems which do not include Zen support. And extra operations are needed to trick the virtualized operating system into believing that it is running on the hardware, bare hardware, which add overhead. In such, the performance impact of full virtualization is greater than with para-virtualization. If you want have to have a great power over that, you can go with full virtualization. Para-virtualization is not as much uh, complete virtualization or provide full support as compared to full virtualization. Additionally, this type of complete machine simulation requires hardware support as well. So, for example, let us suppose a full virtualization example. Uh, some of you may have been trying with Android app development or iOS development. I have been trying it a few years back. Uh, First, for installing Android Studio, the software using which we have to create Android apps, we have to install an emulator or simulator on Mac. We have to install that machine in the virtualization mode, where a typically smartphone could be complete simulated with the complete operating system running on the background, iOS or Android, and we will test our written code or the Android app on that environment first before running in the physical device. So the installation of a AVD or Android virtual device requires the VTX service of your processor, either AMD, Intel, to be turned on. So the VTX service is an hardware support for this kind of virtualization. Without this support, you could not implement the full virtualization. So this was an example. Similarly, you can do with Zen as well. Then there comes the hardware consideration for requirement. The minimum requirement should be 256 MB RAM per domain or per image, 6 GB hard drive per domain, the processor with PAE support, and additional considerations could be the CPU with VT, the virtualization technology VTX or VT in short, the SVM for full virtualization, as I've told you before, a shared storage for live migration, actual storage that is required with will be varying by applications, space on a hard disk. Now we are going to learn about preparing the domain zero. We have to install the domain zero as normal. You have to boot Zen hypervisor and then start XEND management domain or Zen domain. The first domain started in Zen environment is a specially managed domain, that is Zen domain zero. It has the special privileges to manage the hardware devices. It is also the only domain from which an administrator may send commands to the hypervisor. Installing a Zen environment is an easy as installing RHEL, not a problem. You can install with the domain zero. It must include utilities needed to create, manage, and destroy domains. These will be included if you select virtualization support as part of your initial operating system. During installation, when we are installing RHEL image for the first time, you have to enable the Zen or virtualization options. You may turn it on or off anytime later after installation. Without XEND daemon, XEND or Zen daemon in short, running, without it being running, you cannot view or even start domain view. You have to start it. You can check it always with the PS or PS3 command whether it is running or not. Note that although domain 0 is automatically created when Zen starts, The operating system running in domain 0 must be configured to install Zen daemon at boot, which is easily accomplished with a chkconfig command. A daemon is simply a background process, and Zen executes as a background process. The virtual resources like CPU, which is being used, the vCPUs in short, the virtual CPUs, it need not to map directly to the real CPUs. It could be an imaginary part of RAM or other fast devices. The storage is block devices or simple files. Network devices are need to be bridged or routed to domain 0. By default, mapped to Zen VR0. The domain U configuration is defined as per domain U standards. It has virtual block devices, CPUs, networking, and it can be configured by going directly in the domain section of etc Zen directory. You can also find various Zen settings configuration in the etc Zen directory. Now you can install a new domain U with a virtual manager or VIRT manager, which is a graphical front end for managing domains or images. It provides a wizard for setting up new domains. It provides an options. Uh, Command line alternative for virtualization manager is XM. You have to use XM command in the virtual console or Linux terminal to access the virtual manager. It defines the name of the domain, the select storage type, and the number of CPUs. Remember one thing, domain uses a selection of images and which is stored within the hypervisor or domain 0. You have to first install domain 0 or the hypervisor, then afterward any image of the operating system or domain U. You can install multiple domain U within a domain 0 or hypervisor. To select storage type and number of CPUs, you have to specify location of the installer and optionally a kickstart file. The domain management with Zim could be connected with the controlling domains, the monitoring using various commands, the XM command for shutdown, save, restore, pause, create, destroy. You can show the list of the domains, number of list by typing the command XM list. You can also select the top domain, Zen top, and the console, Zen console. You can activate domains on boot. The Zen domain system V or virtualization init scripts. It starts or stops domain U. You must link domain configuration file to etc Zen auto automatic load. Uh, the Zen domains init script can be used to select the domain used automatically when domain O0 is booted. When the hypervisor starts, domain UR can be configured a particular image to be executed after its hypervisor is being booted. The script also takes care of shutdown of the domain use and when domain 0 is shut down. Uh, so this is what we have learned about Zen. Zen is not a very wide topic. The simple topic you have to remember about domain 0, domain U, the hypervisor and the images, the para-virtualization, the full virtualization, and so on. It may sound simple, but everything else that we are learning under RHEL from commands to from file system can be simulated with virtualization. So you have a separate OS running on different OS. The virtualization is also being implemented along with the containerization. Suppose you have been in the field of software engineering or DevOps or testing, you might need to configure uh, things like Docker, Kubernetes clusters, and so on. That runs in a virtualization environment. Uh, so we could be using these things. Zen is a powerful tool. You should utilize it for a wide range of things. So keep learning and keep moving ahead. We will be learning more in the coming videos. Welcome back, friends. Throughout the course, we have learned about installation, uses of file system, permissions, installation of various utilities, the network clients, and everything else, the virtualization and a wide range of things. When you are done with installation and you are a proper user of your system, there are certain scenarios where your system may crash down or do not perform exactly as you are planning to, you are expecting it to perform. Then there comes a need to troubleshoot what are the problems. You should test it. You should be aware of what is going on, and you should be able to fix it. You should not call a maintenance guy every time if you have a problem. That keeps the cost very high. It is not secured enough. The option is not secured, and you should be aware of various things, the precautions, what you could take uh, for running of your the proper running of your system. Friends, we are going to learn all these things here in this lecture, that is troubleshooting. We will learn how to develop a strategy for troubleshooting, how to fix problems in different areas of the Linux environment, boot the system into various run levels. The run levels we have learned. Use the rescue environment as well in case we have left with a troublesome scenario. The first method is to do a fault analysis. We have to first analyze what the problem has occurred before going further in fixing it. If we don't know, let us take a simple case. If a doctor does not know what the problem is, suppose you have a fever and you have asked doctor that I have a pain in my head. He gives you another medicine. However, he should be treating you differently. Before knowing the cause, you could not kill the symptoms. You should not fix the problems. The fault analysis is dealing with these things. It has to characterize the problem. We have to characterize problems into different categories and try to reproduce the problem for learning what it may could do, to find further information about what are the problems, the possible reasons, and the fixation methods. We have to eliminate the possible causes, try the easy things first. We have to back up configuration files before changing. uh, we have to characterize, we have to reproduce, we have to eliminate possible causes, and we have to back up the old problems. Fault analysis deals with gathering of data. We have to gather all the data first. So for gathering of the data, there are few very important or useful commands that will help you gather different data. Suppose the problem could be initialized due to running of a malicious, sorry, not malicious, a problematic or a nuisance commands that are there. Either you have mistakenly executed those commands, or maybe some other users had done that remotely, or some kind of hacking, or simply a mistake. You may kill a process without knowing the process is very vital to a system. You may upload the kernel, update the kernel in a upgrade or fast mode. The useful commands could be history. History will show you last 1,000 commands that a user have executed that is not dependent on a particular session. Even in the previous or more than previous sessions, you could see the command list. Then there is a useful command called grep, which is used vitally. Then there is a command called difference, which could differentiate between the content of different files. You could use the find cmin command that could be allow you that could allow to list all the files that have been modified within a particular range of time, say 60 minutes. For 60, you have to use the strace command for tracing of further data from the application. Uh, it could be used with a PID, the process ID of the running process. Then you have a tail command in the log file entry. Tail shows the last records from the bottom, the recent records, log entry, the user and the details. Then there are you can generate additional informations by running the debug in system log and the debug option in application. Then there are things to check that may cause error sometimes. X window or X can sometimes be problematic. The first thing to try is when confronting X problems, you can go with a system config display, which is a GUI option where you can check X configuration. It should The problem could be occurring in run level 5 generally. It could make logging in impossible in X or in virtual console. You should reboot the system in run level 3. Sometimes viewing the output of X command itself is revealing. It may show you what the errors are. The probe only switch will perform all the tasks necessary to install a X server without actually starting it. And the startup message are displayed. If the text scrolls off the screen, the material of the screen can be viewed by holding the shift key. You could learn with these things. Uh, Try system configuration first. The xprobe could be used if home or temp or the temporary file is full or has the user reached a hard quota. You should be considering to delete the temporary files or recheck the home directory. You should move, change, or sorry, you should move some important files from the home directory to other directories, or you should check XFS, either it is running or not. The XFS font server is the only font path entry uh, in the XOR configuration that is dealing with X11, which is located in the etc directory. If it is not running, X will run. Make sure that XFS is configured to run in the appropriate run levels. Occasionally, it may be necessary to delete stale lock, PID, process ID, or socket files. You should be dealing with a X window and properly check whether it is running. For debugging, you should not be running X in run level 5. You should be running in run level 3. Then there comes things to check, that is networking. You should be checking network. There could be a problem regarding network. For network configurations, the hostname resolution problems, which can create problem for clients and server similarly. Uh, Beside from requiring successful forward lookups, reverse lookups are essential for many host-based security mechanisms. Tools like Host and Dig are invaluable for determining whether host name resolution problem exists or not. If configuration may be IP configuration may be checked using the ifconfig command. You can use the ifconfig for checking the IP address and other details. It shows IP version 4 and IP version 6 details, which one is configured. You can resolve the host name with writing the dig command, dig, provide the URL name next to it, followed by spacebar. The default gateway could be checked with a route command. It could route you to all the path, the gateway, and other details. The netstart R or netstat rn command will show if the system routing table is correct or not. For the data packets, you can check the module specifications and the device activation as well. Then you should be checking the order of boot process. Suppose your system is not starting properly. By default, you have an operating system RHEL installed on your hard disk, in your internal hard disk of your PC, and for some reason uh, it is not starting up. It is showing a boot error. When you are trying to start, it will prompt you with a boot menu. So what is the reason how the system has been crashed down? There might be a scenario where the boot process or boot order could be changed for various reasons. The default boot order is with the preference to hard disk, the internal hard disk. Next is a USB or external hard disk or CD-ROM. For some reasons, mistakenly, the pen drive or CD-ROM could be preferenced more than your hard disk, or some error may have been done, and the pen drive is constantly running inserted on your system, and it has a crashed or improper image installed on it, and you are not able to insert one. You can change the boot order and make the hard disk to boot first. if you require a hard disk, otherwise other tools. In order to troubleshoot boot time process, you must understand the boot process itself, the issue, the cause, and various things, the BIOS settings, the possible causes, the group could be misconfigured, the boot sector is corrupt, the BIOS settings such as this addressing scheme that could be modified since the last boot sector was written, the kernel does not load at all or load partially before a panic occurs. The possible causes could be corrupt kernel images, incorrect parameters passed to the kernel by the bootloader. Then there could be issues like kernel load completely, but panic or fails when it tries to mount a root file system in the init directory. The possible cause could be bootloader is misconfigured in init, the sbin init, or which is corrupted. Init tab is misconfigured, or root file system is damaged or unmounted. You could be dealing with RAID or other things. You should start init with a etc directory, going to the etc directory, the rc.daemon or rc.system init. You can enter run level X using rc.local, the X, and other configurations. The file system corruption, which is common after crash or improper shutdown. Sometimes the system may have improperly shut down, so due to crash or software crash or other driver crash, then the problem could exist. The ext2 mounted for writing marked as dirty. If not mounted or mounted in read only, it should be clean. If not mounted as dirty, it may be corrupt. A repair require exhaustive check. ext3 file system usually marked as clean. The journal indicates if a recovery is needed. Only needed to check files recorded in journal. The file system recovery could be done when if a root has a journal, kernel examines it as a boot. The file system recovery could be done in the rescue mode. Uh, the etc, the system config phase, the file systems marked in fstab. The fstack is a front end to other programs. A field fstack must be run manually. You could configure the recovery run levels to pass the run levels to init on boot from grub splash screen from shell prompt using init or telinit could be used. In run level 1, the process rc.systint and rc1.d daemon script could be used. In run level S or single, the process only rc sysint is running. In emergency, only su login works. So you can go with su login. The booting in level 1 will cause the system to process the system init script followed by each of the init script to be executed. Uh, in safe mode or single mode, run level S, the system calls will start rc-syst init without the init. The init tab could be used. You can still boot into single mode. It is given that you are given the root shell with no scripts processed. And in emergency mode, while technically not in a run level, the emergency mode shares many characteristics of the uh, other run levels, but you can only access emergency mode during boot by passing emergency as a parameter from the grub prompt. You can go directly with the emergency mode after a grub screen shows up. No script will be processed and you are given a root shell without processing the init or other scripts. The rescue or environment is requires when a root file system is unavailable, a non-system specific boot, you can boot from CD-ROM, boot from diskboot.image on USB key, which could be done. The rescue environment exists within a RAM disk image. Because of the limitations on size of the number of inodes, the table for directories, many familiar utilities and device nodes are not available. However, tools related to disk maintenance uh, and network connectivity are provided. You can go with the rescue mode if nothing works out. The rescue environment utilities uses disk maintaining utilities, the networking utilities, miscellaneous utilities, the logging with Anaconda and syslog. The rescue environment details could be configured with file system reconstruction. The Anaconda will ask if file system should be mounted. You have to provide a path variable for that thing. The file system nodes could be used. Uh, the rescue environment will attempt to reconstruct the hard disk file system under the mount points, the sys image, system image. Since a rescue environment is often used on the system with damaged or misconfigured file system, the operation might or maybe not working. You can go with a fdisk available under Alt F2 the option. Uh, you should hang the command prompt uh, a terminal. You should carefully inspect the output of the mount command that should determine the state of the reconstructed file system. The file system could be configured here as here. The mk command is useful here, and you can go with a GUI utility that is system specific device files and so on. So this was a few techniques of what is the role of troubleshooting, how we can construct a problem, reconstruct a fix, and work in a rescue mode or other safe modes in different run levels and other things in case a trouble may occur. You should be planning troubleshooting since you have installed your device OS. Uh, Troubleshooting is not very hard often, but sometimes it could be complicated as well if you have not prepared and do not know much about it. A problem is not a problem at all. When a problem occurs, it is an opportunity for those who may learn from those problems by trying various things. And in the next time, if the problem occurs, they could be able to fix that thing. So a problem is not a problem at all. You should be able to troubleshoot. Uh, Try fixing these things. Be familiar with shell commands and other things. Linux is a very useful thing. You should be using it, and the power of RHEL is very big. Consider it uh, very carefully and keep learning and keep practicing various commands or utilities. Go with configuration files. We will be learning more later. You should be practicing various exercises, and RHEL is yours. Now you can build your own server environment or your own desktop utilities. Start working on RHEL. RHEL is a good solution. So keep learning and keep moving ahead.